ala asyrafil anbiya'i wal mursalin Sayyidina wa maulana Muhammadin wa ala alihi wa ashabihi ajma'in. Amma ba'du. Allow me to warmly welcome His Excellency Dr. Hanif Faisal Nurofik, the Minister of Environment of the Republic of Indonesia, who is joining this conference virtually. Respectable Bapak Insinyur Nur Adi Wardoyo, MSc, the Senior Advisor, the expert staff for biodiversity and socio-cultural sustainability, the Ministry of Environment, Republic of Indonesia. Welcome to Universitas Islam Malang. The Honorable Rector of Universitas Islam Malang, Professor Dr. Andes Haji Junaidi, MPD, PhD, and all the Vice Rectors in Universitas Islam Malang. Honorable the keynote speakers of IC-BioTEStA 2025, Profesor Mahani Matnur from University Kebangsaan Malaysia, who already joined us in person. Thank you very much for coming in Universitas Islam Malang. Profesor Mulyoto Pangestu from Monash University, Australia. Profesor Anneli Petrisans from University of Lorraine, France. Profesor Nur Atiroh Abdusyakur MKes from Universitas Islam Malang, Indonesia. Professor Delvak Osiandi from the University of Manchester, England. The Associate Professor Bin Huang from Kaohsiung Medical University, Taiwan, and the Honorable Dr. Mia Guo from King's College London. The Honorable the Dean of Faculty of Mathematics and Natural Sciences, Universitas Islam Malang, Professor Hussein Latukon Sina, MSE, and all the Vice Deans. The Chairman of IC-BioTEStA 2025, the Associate Professor Ahmad Shauki, MSE, distinguished moderators, respected presenters, all the faculty members, the committee members, ladies and gentlemen who join virtually and on-site. Distinguished professors and participants, good morning and welcome to the first International Conference on Biological Technology for Sustainable Natures, or IC-BioTEStA 2025, with the theme, Probing the Valuable Biotechnology for Sustainable Nature, proudly presented by Universitas Islam Malang. Kindly give the round of applause. First of all, let's express our gratitude to Allah Subhanahu wa Ta'ala for His mercy and also blessings so that we can gather here in the IC-BioTEStA 2025 in a good condition. And of course, let's us also send salawat and also salam to our beloved Prophet Muhammad Sallallahu Alaihi Wasallam. The Excellencies, ladies and gentlemen, before we begin, let's recite together Suratul Fatihah. May Allah bless this event with guidance and also success. Ala hadiniyah wa ala kulli niyatin sholihah. Al-Fatihah. Ladies and gentlemen, the next agenda is singing the national anthem of Indonesia Raya and Mars Syubadul Waton. Please kindly be standing.
من الحرمان انهزوا على الوطن يا للوطن يا للوطن يا للوطن حب الوطن من الإيمان ولا تكن من الحرمان انهزوا على الوطن إندونيسيا بلادي أنت عنوان الفخامة كل من يأتيك يوما قومي هيا القومامة كل من يأتيك يوما قومي هيا القومامة Jaga hati wahai tanah airku cintamu dalam imanku jangan halangkan nasibmu bangkitlah hai bangsaku jaga hati wahai tanah airku cintamu dalam imanku jangan halangkan nasibmu bangkitlah hai bangsaku Indonesia negeriku engkau panji martabatku siapa datang mengancammu kan binasa di bawah tulimu siapa datang mengancammu kan binasa di bawah tulimu
Please kindly be seated. Ladies and gentlemen, we sincerely apologize for not mentioning our Unisma Foundation. The Secretary of Unisma Foundation Board, Dr. Haji Mohtar Data MPD, and also all the entire board. Thank you very much for coming here. Well, ladies and gentlemen, the honorable audience, we will now continue with the recitations of Salawat Nuril Anwar together.
Allahumma salli ala Muhammad. Allahumma salli ala nuril anwar wasiril asrari wa tiryakil ومفتاح باب اليسار سيدنا ومولانا محمد المختار وآله الأطهار وأصحابه الأخيار عدد نعم الله وإفضاله عدد نعم الله وإفضاله.
Thank you very much. Ladies and gentlemen, now we would like to respectfully call upon the Dean of Faculty of Mathematics and Natural Sciences, Universitas Islam Malang, Profesor Husain Latukonsina MSI, to deliver his address. Please kindly give the round of applause for Bapak Profesor Husain Latukonsina.
Bismillahirrahmanirrahim. His Excellency Mr. Hani Faisal Nurofik, Minister of Environmental of the Republic of Indonesia, respectable Mr. Nur Ariwadoyo, MSc, Special Advisor and Expert Staff for the Preservation of Social Cultural Biodiversity Resources, Minister of Environmental of Republic of Indonesia, respectable Secretary of the Advisory Board of Universitas Islam Malang, Foundation Dr. Mokhtar Data, MPD, respectable the Chairman of Universitas Islam Malang Foundation, Professor Dr. Agus Sugianto, STMP, respectable Rector of Universitas Islam Malang, Professor Junaidi, MPD, PhD, respectable Vice Rector in Universitas Islam Malang, respectable Prof. Dr. Mahanem Binti Matnur from University Kebangsaan Malaysia, and respectable Professor Bin Huang, PhD from Huaishuang Medical University, Taiwan, respectable Professor Mulyono Pangestu, PhD from Monash University, Australia, respectable Professor Dr. Nur Atiro Abdul Shakur from University Islam Malang, respectable Professor Delphak Oceandi, MPD, PhD, from University of Manchester, England, respectable Professor Annelien Patricians from University of Lorraine, France, respectable of Dr. Mayu Guo from King College University, London, respectable distinguished member of the Scientific Committee of the First International Conference on Biological Technology for Sustainable Nature, IC-BioTESTA 2025. Respectable presenter and participant, and ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. And good morning. My name is Professor Dr. Hussein Latukun Sina, Dean of the Faculty of Mathematics and Natural Sciences, Universitas Islam Malang. I'm honored of the serve as the General Chair of the first International Conference on Biological Technology for Sustainable Nature, IC-BioTESTA 2025. The idea for organizing IC-BioTESTA originated from our Vice Rector for Academic Corporation Affairs, Dr. Erna Sulistiwati, MKS, PhD, who proposed the establishment of an international conference focusing on biology. She entrusts the Faculty of Mathematics and Natural Sciences, particularly the biology of program study, with the responsibility of hosting this important event. Department of Biology, Faculty of Mathematics and Natural Sciences was established in 1989 and proudly celebrating its 36th anniversary this year. It has achieved the highest accreditation rating excellent from the Independent Accreditation Institute in Indonesia and supported by a diverse faculty organized into three main fields: expertise, biotechnology, biomedicine, and biology conservation. The conference is a part of faculty strategic plan for 2025 and contribute directly to Universitas Islam Malang milestone of becoming a world-class university. It's our hope that IC-BioTESTA will be held regularly at our faculty, strengthen the international of our study program and supporting the university's journey toward world-class university, inshallah. We also approach to announce the proceeding in the conference will be published in the bio web of conference with the index in Scopus in a mark history milestone of the first international conference at University Islam Malang to achieve Scopus index proceeding publication output. In the same year, the Faculty of Mathematics and Natural Science has also initiated a new department, Environmental Science, approached to by Rector University Islam Malang, Professor Dr. Junaidi, MPD, PhD. This program reflects to university long-term commitment to developing competent human resources capable of addressing environmental challenges at the regional, national, and the global level. We hope the IC-BioTEStA 2025 will make a meaningful contribution through research and scholarly discussion in biology and related field, supporting sustainable development in the Indonesian and beyond. In alignment with the Sustainable Development Goals, at the same time, this conference will further strengthen Universitas Islam Malang path toward becoming a world-class university. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh, and good morning.
Well, thank you very much for the encouraging address from the Dean of Faculty of Mathematics and Natural Sciences, Universitas Islam Malang. Please kindly give once again round of applause for Bapak Profesor Hussein Latukon Sinan. Well, ladies and gentlemen, we now move on to invite Director of Universitas Islam Malang, Profesor Dr. Andes Haji Junaidi, MPD, PhD, to officially open the IC-BioTEStA 2025. Please welcome him with a warm round of applause.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillah rabbil alamin. Salatu wassalamu ala asrafil anbiya'i wal mursalin sayyidina wa maulana Muhammadin. Allahumma salli wa sallim ala sayyidina Muhammad wa ala ali sayyidina Muhammad, amma ba'd. His Excellency Bapak Dr. Hanif Faisal Nurrafiq, Minister of Environment of the Republic of Indonesia, His Excellency Bapak Insinyur Nur Adi Wardoyo, MSc, Senior Advisor to the Minister for Sustainable Biodiversity Resources and Socio-Cultural Affairs. Welcome to Unisma. Pak Menteri juga welcome to Unisma. He is joining us online. The Honorable Secretary to the Advisory Board of the Unisma Foundation, Bapak Dr. Haji Muhtar Data, MPD, and also the Chairman of Unisma Foundation, Bapak Profesor Dr. Insinyur Agus Sugianto, MT, together with his secretary and also Vice Chairman in charge of Education Affairs, Bapak Dr. Mashhuri Mahfud, the Honorable Vice Rectors, Deans in the Unisma, particularly the Dean of the Faculty of Mathematics and Natural Sciences, and of course the respectable keynote speakers we have in our conference today. The keynote speakers including Ibu Professor Mahanim from University Kebangsaan Malaysia. Welcome to Unisma, Ibu. And then Professor Mulyoto Pangestu from Monash University, Australia. Professor Annelie Patrisans from University of Lorraine, France. Professor Delphac Osiandi from Manchester University, UK, England. Associate Professor Bin Huang from Kaohsiung Medical University, Taiwan. Dr. Miao Guo from King's College, London. And also Ibu Professor Nur Atiroh from Unisma, Indonesia. Respectable parallel session presenters, participants, conference committee, administrators, and faculty members who are joining this conference today, ladies and gentlemen. First of all, let's bow our head to thank Allah subhanahu wa ta'ala, the Almighty, for His blessings and mercy that today we can get together either physically or virtually to join our first international conference on biological sciences. Secondly, salawat and salam should go to the Prophet Muhammad sallallahu alaihi wasallam for his guidance in the form of Dinul Islam. Then, on behalf of the Universitas Islam Malang, I am very pleased to welcome you all, our international and domestic keynote speakers, presenters, and participants of this first international conference on Biological Technology for Sustainable Nature 2025. Welcome to Indonesia, welcome to Unisma Malang. Unisma Malang is now on its path of becoming a world-class university. As such, our mottos are: 1. Unisma from Nahdlatul Ulama for Indonesia and world civilizations, and 2. Unisma flies high to be a world-class university. In relation to the goal of becoming a world-class university, then any form of international collaborations such as inbound or outbound visiting scholars, joint teaching, joint research, joint publications, and joint conferences is most welcome. It is at this point that the international conference that we are carrying out now has its own significance. This conference will provide opportunities for researchers, educators, and anyone interested in basic biological sciences, biotechnology, biomedical and pharmaceutical sciences, and biodiversity, and also environmental sustainability, and also the applied sciences of these fields of study to share each other their knowledge, expertise, and experience. We hope that the conference not only brings about scientific papers publishable in reputable proceedings, but also give direct impact on the attempt to preserve and sustain natural resources, the objective of which is relevant to the Sustainable Development Goals 11, Sustainable Cities and Communities. This conference will also be a perfect moment for us to develop our networking and collaborations with scholars across the nations and globes. Then, on behalf of Unisma Malang, we would like to thank the keynote speakers, presenters, and participants for joining this international conference, especially those coming from overseas like Malaysia, Taiwan, Australia, France, and the United Kingdoms. We would also deliver our appreciation to anyone that I cannot mention one by one who has supported this conference, especially the organizing committee from the Faculty of Mathematics and Natural Sciences, Unisma, as the host. Our appreciation also goes to the co-host partners from Kaohsiung Medical University, Taiwan, University Kebangsaan Malaysia, State University of Surabaya, Indonesia. We firmly believe that this international conference will develop our innovations and creativity for advancing technology in biological sciences for a better quality of life for all human beings. We hope that insights from our discussion in the conference can benefit us for personal and professional development purposes. We also looking forward to your participation in other international conferences at Unisma, Malang, Indonesia. Thank you very much and enjoy the conference. Then, by reciting Bismillahirrahmanirrahim, our first international conference on biological technology for sustainable nature is officially opened. Thank you. Wallahul muwaffiq ila aqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Please kindly give once again the warm round of applause for the Rector of Unisma for officially opening the IC-BioTESTA 2025. Thank you very much once again. Well, the Excellencies, ladies and gentlemen, we are honored to welcome His Excellency Dr. Hanif Faisal Nurofik, the Minister of Environment of the Republic of Indonesia, who is joining us today via Zoom platform meeting to deliver his remarks. We kindly give the floor for him. Well, ladies and gentlemen, we also allow the Bapak Insinyur Nur Adi Wirjoyo MSc as the expert staff of Biodiversity and Social Cultural Sustainability, the Ministry of Environment Republik Indonesia, to please kindly moderate the sessions for Bapak Menteri before Bapak Menteri start the remarks or give the presentations of our today conference. The floor is yours.
Yes, thank you. Assalamualaikum warahmatullahi wabarakatuh. Waalaikumsalam. So we are waiting the connection with the Minister of Environment. He is joining us from Serang, Banten Province, and Pak Menteri has committed to join this event. He made a promise to Pak Rektor, and Pak Menteri will fulfill his promise to join this event, because Pak Rektor has prepared this quite some time and has reported to the minister that Unisma will have this event on biodiversity. And so biodiversity is very important to us, and so that we will hear from the prominent speakers from international academics, and so we hope that we can get the lessons and we can share experience, we share ideas, and Pak Menteri will provide the highlights from the government policy direction, and hope that this event will deliver some good recommendations and a good report to the minister for follow-up. So we hope that this seminar is not only not just a scientific discussion, but we encourage that all the speakers will use this opportunity to share their views and experience and to inspire us in more work, practical work with all the stakeholders outside this room. Yeah, so we will hear from Pak Menteri, and we will also from the other keynote speakers. Yeah, and so we will have more complete views of the issues, of these issues, and we hope that we can learn together. Yeah, is the connection ready? Oh yeah. 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 Kalau ibu berikutnya siapa? Oh yeah. Okay. So while waiting for the connection with the minister, so the organizing committee will proceed with the other
Certificates
agendas.
of the keynote
Yes.
speakers. Okay.
Please. Thank
Yes.
you.
Thank you very much for Bapak Nur Adi Warjoyo MSc. So while we wait for the Bapak Menteri coming here with us in Zoom meeting, so we will move on our sessions to the awarding of speakers certificates. So we are delighted to present the certificates of appreciations to the keynote speakers, Bapak Insinyur Nur Adi Warjoyo MSc from the Ministry of Environment, Republic of Indonesia. And also please come forward for Professor Mahanimat Nur from University Kebangsaan Malaysia, and also Prof. Nur Atiroh Abdusyakur MKes from Universitas Islam Malang. Please kindly to come forward. And of course, for this honorable moment, we also would like to invite the board of Unisma Foundation, Bapak Mohtar Data, Prof. Agus, Prof. Ganif, and also Bapak Masyuri Mahfudz, and also Pak Rektor, Profesor Junaidi, MPD, PhD, the Vice Rectors of Unisma, and then the Dean of Fakultas MIPA, Profesor Husain Latukonsina, MSI, to please come forward and accompany the awarding ceremony. Well, ladies and gentlemen, the first token of appreciations will be given to Bapak Insinyur Nur Adi Warjoyo MSc, and the token of appreciations is given by Director of Universitas Islam Malang, Bapak Profesor Dr. Andes Haji Junaidi, MPD, PhD, to Bapak Insinyur Nur Adi Warjoyo MSc. We would like to say thank you very much to him for coming here in the IC-BioTEStA 2025. He is the expert staff for biodiversity and sociocultural sustainability from Ministry of Environment, Republic of Indonesia. Please kindly give the very warm round of applause for him. Okay. The next token of appreciations is given to Professor Mahadi Matnur from University Kebangsaan Malaysia, who already here with us in person. Thank you very much. And the token of appreciation is given by the Secretary of Advisory Board Unisma Foundation, Bapak Dr. Haji Mohtar Data MPD. Excellencies, ladies and gentlemen, please kindly give the round of applause. Well, ladies and gentlemen, the next token of appreciations will be given by the Chairman of Unisma Foundation, Bapak Profesor Dr. Insinyur Agus Sugianto. To our plenary speakers, Profesor Nur Atira Abdusyakur MKes from Universitas Islam Malang. The next agenda is a group photo session. This is the first photo session. And then the second group photo session, please kindly turn around facing all the audiences for the picture, because we would like to take the documentation with the all audiences, presenters and also participants who are now joining here with us on site. And also please be ready for all the participants and also presenters who join online via Zoom meeting platform. Okay, ladies and gentlemen, please be ready. Camera is ready. 3, 2, 1. Okay, and then please gaya terbang melesat. Thank you very much, ladies and gentlemen. Please kindly give a big applause. Thank you very much once again. Well, the Excellencies, ladies and gentlemen, the following agenda is the recitations of prayer, and we respectfully invite the Secretary of Unisma Foundations, Bapak Dr. Haji Mohtar Data MPD, to lead the prayer. Time is yours.
Bismillahirrahmanirrahim. Hamdan sakirin, hamdan naimin, hamdan yuwafi ni'amahu wa yukafi'u mazida. Ya Rabbana lakal hamdu wa lakas syukru kama yanbaghi li jalali wajhikal karimi wa azimi sultani. Allahumma Rabbana atina min ladunka rahmah wa hayyi' lana min amrina rasada. Allahumma la sahla illa ma ja'altahu sahla, wa anta taj'alul hasana idza syi'ta sahla. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wassalamu ala sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Walhamdulillahi rabbil alamin. Al-Fatihah.
Thank you very much, ladies and gentlemen. Alhamdulillahirabbil alamin. The opening ceremony of IC-BioTESTA 2025 has been successfully and also smoothly held or conducted. Of course, on behalf of the committee conference, we would like to sincerely thanks to all the honorable guests, distinguished speakers, and also all the participants and presenters who have joining us online and also offline for their kind attention and also contribution during this opening session. Kindly, once again, ladies and gentlemen, give the round of applause for the successful of our opening ceremony. Distinguished speakers and also presenters and participants, we kindly invite to all of the participants to stay engaged and also attentive since we are now moving forward to the most awaited part of today's program, which is the keynote session. It is a very great honor to introduce our first keynote session, Bapak Insinyur Nur Adi Wardoyo, MSc. Since Bapak Menteri has not come yet in our Zoom meeting, so is it okay if we start? He has not yet come here. Prof. Muhammad, is it okay? Will you be the first keynote speakers today? Okay. Okay, so Bapak Menteri will come around 10 minutes again. Okay. Well, ladies and gentlemen, before we start the following keynote session, we will have a break for a while. After this, Bapak Menteri will join here with us in the Zoom meeting. So thank you very much for all the distinguished guests who have support and also come to our opening of International Conference in the IC-BioTESTA 2025. Thank you very much.
Bu WR1, kami mohon untuk bisa di depan, Pak Dekan.
Unisma Malang. Sesuai dengan pedoman keamanan, kesehatan, dan keselamatan kerja di lingkungan Unisma, kami akan menginformasikan terkait pedoman keamanan dan ketiga yang berlaku di Unisma sebagai berikut. Hadirin tidak diperbolehkan untuk merokok di lingkungan gedung B, kecuali pada ruangan bebas rokok. Pastikan puntung rokok Anda sudah mati sebelum membuang di tempat sampah. Gedung Utsman bin Affan dilengkapi dengan 2 lift yang terletak di tengah gedung. Masing-masing memiliki kapasitas 11 orang dengan maksimal beban 825 kg. Ketika Anda memasuki lift, pastikan penggunaan sesuai dengan kapasitas. Jika terjadi kerusakan dan terjebak di dalam lift, jangan panik. Hubungi petugas dengan menekan tombol darurat pada lift, kemudian petugas keamanan akan segera menolong Anda. Gedung Utsman bin Affan terdiri dari 7 lantai. Pastikan Anda mengetahui posisi saat ini dan luangkan waktu sejenak untuk mengetahui pintu darurat atau jalur evakuasi berada. Apabila terjadi gempa bumi, tetap tenang dan jangan panik. Jika Anda berada di dalam ruangan, segera berlindung di bawah meja. Lindungi kepala dan dari benda-benda yang gampang terjatuh. Tunggu sampai keadaan benar-benar kondusif. Ketika goncangan berhenti, segera keluar ruangan secara teratur melalui tangga darurat menuju titik kumpul yang berada di halaman utama kampus. Utamakanlah lansia, ibu hamil, atau teman yang mempunyai penyakit kronis. Dalam keadaan darurat, tinggalkan barang-barang Anda, dan jika Anda memakai sepatu dengan hak tinggi, mohon dilepaskan dahulu untuk memperlancar proses evakuasi dan menghindari terjatuh pada saat evakuasi. Pakailah tangga yang terletak di tengah dan barat gedung. Hindari menggunakan lift. Apabila terjadi kebakaran, tetap tenang dan jangan panik. Segera keluar melalui pintu darurat. Ikuti jalur evakuasi untuk menuju titik kumpul. Gedung ini dilengkapi dengan detektor asap. Secara otomatis menunjukkan fire alarm jika terjadi kebakaran. Di setiap lantai gedung Utsman bin Affan dilengkapi dengan alat pemadam api ringan atau APAR yang terletak di sebelah tangga. Demikianlah prosedur keselamatan ini kami sampaikan. Kami harap Anda tetap tenang jika terjadi keadaan darurat. Ikutilah arahan dari pihak keamanan. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Dari sebuah pilihan, tapi kemana langkah harus melaju. Universitas Islam Malang hadir sebagai gelombang tertentu dan melangkah dunia global yang tetap berpijak pada agar luhur berlandaskan Islam as-sunnah wal jamaah. Di sini, mahasiswa tidak hanya belajar para ahli, tapi juga diskusi dan bereksperimen di laboratorium, perpustakaan, serta praktik lapangan. Dengan fasilitas modern, kolaborasi dan berbagai inovasi yang terus menyala, Unisma menjadi kampus unggul dan bersaing global serta melahirkan lulusan yang siap bersaing di berbagai bidang. Membawa semangat perubahan dan kontribusi di kemajuan peradaban dan berkelanjutan. Pilihan hari ini tentu masa depan hebatmu. Bersama Unisma, terbang melesat menuju kampus berkelas dunia.
Welcome to the library of University of Islam Malang. Unisma Library was established on March 27, 1981 in conjunction with the establishment of Unisma Malang. It has 4 floors with a total area of 3,414 square meters. Unisma Library has implemented strict protocols to tackle the spread of COVID-19 virus.
does not only provide interesting readings, but also has furnished by unique interior design in each floor. On the first floor, there are various kind of corners. They are literacy room, photocopy service, library.
Good morning, Bapak Menteri. We would like to extend our warmest welcome to His Excellency Dr. Hanif Faisal Nurofik, the Minister of Environment, the Republic of Indonesia. We are very, very honored to have you in our IC-BioTESTA held by Universitas Islam Malang in 2025. Welcome in Unisma. Ladies and gentlemen, all excellencies, we are very honored to welcome him, His Excellency Dr. Hanif Faisal Nurofik, the Minister of Environment of the Republic of Indonesia, who already here with us, joined via Zoom meeting to deliver his remarks. We also would like to invite Bapak Nur Adi to deliver his introductory remarks. Okay, no need. Well, ladies and gentlemen, kindly give the round of applause for Bapak Menteri, Bapak Dr. Hanif Faisal Nurofik, the Minister of Environment, the Republic of Indonesia.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Kami hormati
Waalaikumsalam warahmatullahi wabarakatuh.
Sekretaris Dewan Pembina Yayasan Unisma, Dr. Haji Mukhtar Data MPD, Ketua Umum Pengurus Yayasan Unisma, Profesor Dr. Insinyur Haji Agus Sugianto STMP, Sekretaris Pengurus Yayasan Unisma, Insinyur Haji M. Ganif Wiriantono Setiawan MM, Wakil Ketua Bidang Pendidikan Dr. Insinyur Haji Masyuri Mahfud MP. Kami hormati Bapak Rektor Unisma Profesor Dr. Haji Junaidi MPD PhD, keynote speaker from Malaysia, Profesor Honorable Profesor Dr. Mahanin Binti Matnur, keynote speaker from Australia, Honorable Prof. Mulyoto Pangistu, keynote speaker from France, Honorable Professor Anili Pratishan, keynote speaker from Indonesia, kami hormati Profesor Nur Atiroh AS MKes, keynote speaker from England, Honorable Professor Delfak Osiandi, keynote speaker from Taiwan, Honorable Ashok Prof. Bing Huang, keynote speaker from London, Honorable Dr. Miao Guo, kami hormati dari Universitas Islam Malang, presenter, moderator, dan partisipan, Dekan Fakultas Peternakan, Dr. Dewan Nurul Humaidah MKes, Dekan Fakultas MIPA, Dr. Husain Latu Kosnina SPI MSc. Distinguished speakers, esteemed scientists, respected policymakers, and honorable participants, I am warmly greet you all and express my sincere appreciation to Universitas Islam Malang for hosting IC-BioTESTA 2025 and celebration of the 44th anniversary. This conference not only a milestone of academic excellence, but also a time to action, reminding us that Indonesia biodiversity policy must be aligned with the global sustainability agenda. Let us this gathering as a platform to bridge science, policy, and community engagement, ensuring that our nation, rich nature heritage continues to thrive, a part of our shared global responsibility. Biodiversity is often described as a living fabric of our planet. It is foundation of our food, our health, and our economy. Yet, this living fabric is flying faster than ever before. The IC-BioTESTA target, adopted under the Convention on Biological Diversity for a period 2011 until 2020, we were 20 goals global goal designed to reduce pressure on ecosystem, conserve species, and integrated biodiversity into policies and practices. According to the Global Biodiversity Outlook 5, none of these targets were fully achieved. At the same time, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, IPBES, the world's leading scientific body on biodiversity, works through its global assessment that nearly 1 million species could face extinction with decades. The drive, deforestation, over-exploitation, climate change, pollution, and invasive species continue to intensively. With the COVID-19 pandemic further underscoring humanity depends on health ecosystem. For Indonesia, the warning carries special weight. We are one of the world's true mega diversity countries, second only to Brazil. Our 17,000 islands shelter extraordinary ecosystem rainforest, a mangrove, a peatland, coral reef, and seagrass beds. On land, we host nearly 10% of the world's flowering plant, 15% of the mammal, and 17% of birds. And our sea, we are at the heart of the coral triangle, home to 3/4 of the world's coral species and more than 3,000 species of fish. These ecosystems are not just beautiful or unique. They feed millions of families, protect our coastline, store billions of tons of carbon, and inspire our culture and identity. But let us be honest, these rights are under serious pressure. In less than 2 decades, we have lost close to 10 million hectares of forest. Half of our fish stock are already overfished. Coral reef which support a whiter all marine life. Coastlines vanish with only 1.5 degree of global warming. Add to this the growing threat of plastic pollution, invasive species, and climate-driven extreme weather, and it's become clear the biodiversity crisis is also an Indonesia crisis. Towards recognize this urgency in 2022 by adopting the Kunming-Montreal Global Biodiversity Framework. It set ambitious target, conserving 30% of land and sea by 2030, restoring degraded ecosystem, cutting pollution in half, and mobilizing $200 billion annually for biodiversity. Its vision, living in harmony with nature by 2050, is ambitious but essential. For Indonesia, as a mega diverse nation, this is not only a global promise, but a national duty. To answer this call, we have prepared the Indonesia Biodiversity Strategies and Action Plan 2025 until 2045, or IBSAP. It integrated biodiversity into our long and medium-term development plans. Its goals are clear: protect and restore ecosystem, ensure that biodiversity is used sustainably, and strengthen governance, science, and financing. For the first time, we are also using a biodiversity management index, a way to measure with data how well we are protecting species, ecosystem, and genetic diversity. This put Indonesia at the forefront, a country that treats biodiversity not just a slogan, but as measured priority. Still, no plan can succeed without financing. Indonesia needs estimate $2.5 until $3 billion each year to meet our biodiversity goals. We are addressing the gap with innovative solutions, biodiversity credit, coral bonds, and blended finance. This tool links financial returns directly to conservation outcomes. For example, a coral bond can fund reef restoration with repayment tied to ecological results, and environmental fiscal transfer rewards local government for protecting forests and mangrove. These efforts ensure that protecting nature is no longer a burden but an investment. But policy and money alone are not enough. We must recognize the people who have been conserving biodiversity for generations, local people and local communities. Globally, 80% of remaining biodiversity is found in their territories. Here at home, Sasi Laut in Maluku regulates season fishing. Hutan adat in Kalimantan protected rainforest, and Bali Subak system integrated agriculture with culture and spirituality. These practices are living proof that conservation and culture are inspirable. By recognizing and supporting this system, Indonesia shows that protecting biodiversity is also about protecting identity, dignity, and justice. Science and innovation must also play their parts. Today, we can use satellites, artificial intelligence, and genomic research to monitor ecosystem in real time, track indigenous species, and safeguard genetic diversity. Conferences like IC-BioTEStA 2025 are helping us link these scientific advances with policy making. They show us that biotechnology are through technology and computational biology are not abstract science. They are practical tools that can help us conserve nature, while also creating solutions for food, health, and climate. This brings me to an opportunity that calls Save Indonesia Future. Bioprospecting means systematically exploring our biodiversity, plant, animal, microorganisms for valuable compounds and knowledge that can be used in medicine, agriculture, renewable energy, and industry. Globally, in the sector is worth up to $100 billion. And with our extraordinary biodiversity, Indonesia can become a leader in this field. Emerging medicine derived from rainforest plant, sustainable bioenergy from mangrove ecosystem, or new agriculture varieties developed from our genetic resources. But we must proceed carefully. Without strong safeguard, bioprospecting can turn into piracy when genetic resources or traditional knowledge are taken without consent, without recognition, and without benefit sharing. Indonesia has already faced such success with foreign expansion on our plan and unauthorized collection of genetic material. This is why we ratified the Nagoya Protocol on Access and Benefit Sharing. It requires that when resources or knowledge are used, benefit, whether royalty, technology transfer, or community development, are fairly shared with those who are there through custodian. For Indonesia, bioprospecting can become a bridge between conservation and development. To make it work, we must ensure three things. The first, consent. Community must be fully informed and must agree before any exploration takes place. 5. Benefit. From royalty and licensing to technology, training, and health costs. Protection of traditional knowledge through national register and legal safeguard against unfair claim. Don't write, bioprospecting will transform biodiversity from something we simply protect into something we actively nurture and benefit from, while ensuring that the people who have safeguarded this knowledge for countries, centuries, and honor of and rewards. Our leadership must also extend beyond our borders. We can champion short cooperation, sharing sessions on mangrove rehabilitation, wetland restoration, and community-based conservation with other developing nations. At the same time, we can build partnerships with developed countries and private investors to mobilizing financing and technology. Indonesia can be a bridge between the goal sought and the global sought and the global north in shaping a fair, effective and inclusive biodiversity agenda. In the end, the challenges before us is also an opportunity. If we delay, biodiversity loss will accelerate, eroding our vision on Indonesia as one of the world's top economy by 2045. But if we act now with courage, innovation, and fairness, we can place biodiversity at the heart of our green and blue economy. We can build resilience against climate change, secure food and water, and create new opportunities for innovation and jobs. Let this be our call to action, for government to lead with vision, for scientists to innovate with responsibility, for business to invest with conscience, and for community to remind the stewards of our shared heritage. Together, we can ensure that Indonesia rise not only as a biodiversity superpower, but also as a global leader in building a future where people and nature truly thrive side by side. Wassalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Thank you very much. A very valuable presentation delivered by His Excellency Dr. Hani Faisal Nurofik. Thank you very much once again. And of course, on behalf of the conference committee, we would like to sincerely thanks to you, to His Excellency Dr. Hani Faisal Nurofik, for the meaningful address and also knowledge he just shared with us today. Again, thank you very much. Please kindly give a big applause for Bapak Dr. Hani Faisal Nurofik as the Minister of Environment, the Republic of Indonesia. Well, ladies and gentlemen, we kindly invite all the participants to please keep engaged and also attentive, because we are now moving on to the next agenda, the most awaited session for today's conference, with the keynote session Bapak Insinyur Nur Adi Wardoyo. Okay, so the next first keynote speech session will be delivered by Ibu Profesor Mahani Matnur from University Kebangsaan Malaysia, who already joined here in person. And of course, to guide this session, I hand over this keynote speech session to our moderator, Ibu Dr. Hajah Erna Sulistiawati MKes PhD. Please give the round of applause.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alright. His Excellency Mr. Hanif Faisal Nurofik, Minister of Environment of the Republic of Indonesia, respectable Mr. Insinyur Nur Adi Wardoyo, MSc, Special Advisor and Expert Staff for the Preservation of Socio-Cultural Biodiversity Resources, Ministry of Environment of the Republic of Indonesia, respectable the Secretary of the Advisory Board of Universitas Islam Malang, Dr. Haji Mohtar Data, MPD, and respectable the Chairman of the Universitas Islam Malang, Universitas Islam Malang Foundation, Professor Dr. Insinyur Haji Agus Sukianto STMP, the respectable Rector of Universitas Islam Malang, Professor Junaidi MPD PhD, and all the presenter and keynote speakers. For the first keynote speaker will be delivered by Professor Mahanem Matnur, PhD from Universitas Kebangsaan Malaysia. Her topic is about male reproductive biology with the title presentation Dual Health Benefits of Moringa oleifera from Metabolic Regulation to Fertility. Okay, I give for Prof. Mahanem to give your time to present your presentations.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much to Dr. Erna. His Excellency Mr. Hanif Faisal Nurofik, Minister of Environment of the Republic of Indonesia, respectable Mr. I.R. Noyer Adi Wardojo, Special Advisor and Expert Staff of the Preservation of Cultural Biodiversity Resources, Ministry of Environment, Republic Indonesia, respectable Secretary of the Advisory Board of University Islam Malang Foundation, Dr. Mohtar Data, MPD, respectable the Chairman of University Islam Malang Foundation, Professor Dr. I.R.H. Agus Sujianto, respectable Rector of Universitas Islam Malang, Professor Dr. Junaidi, MD, PhD, respectable Vice, respectable Vice Rector Hussein, which one? Our Dekan Hussein, Professor Dr. Hussein, and then we have all the keynote speaker and also all the participants. Okay, so to the respectable all presenter and participant, and ladies and gentlemen, so I'm very pleased and very happy to be invited in Unisma in IC-BioTEStA 2025 conference. And as for today, I will share my topic regarding to actually SDG 3 and SDG 8. Yeah, it's about for our health and for economic importance. Okay, so may I have the slide, please? The slide. SDG 3 is for health and well-being, and then SDG 8 is for economic growth. So we use a medicinal plant for health and how to use that for income generation for economic purposes. So maybe while waiting for the technical, share my slide, maybe I can give some brief my background on my research. Okay, so my research or my expertise is on male reproductive health. Okay, so I work with medicinal plants, so we screen quite a few or several medicinal plants with a potential of for beneficial effect on our health, for metabolic disorder, to overcome metabolic disorder, as well as for fertility. Okay, so that is my first slide. So this is the title of my talk for today. So dual health benefits of Moringa oleifera, from metabolic regulation to fertility. Okay, so first and foremost, I would like to present my presentation outline. So we have next slide. So we have the first is my introduction on global health challenge here, because we have a problem with metabolopathy. It's referring to metabolic disorder towards male infertility problem. Okay, so I will brief the introduction, okay, on these metabolopathies and male fertility problem. And then we're moving on to the second topic on Moringa oleifera, as a potential for metabolic regulation and male fertility enhancer. Okay, so then we have I divide topic B into two subtopics. How Moringa oleifera has anti-diabetic as well as male fertility enhancer. And then we have Moringa as an anti-obesity and male fertility enhancer. Okay, so next topic, we go on to brief introduction on global health challenge regarding to metabolopathy and male fertility. Okay, so next, okay, so this is just a brief definition. This is quite a new term. Metabolopathies is actually something to do with a metabolic disorder, resulting from dysfunction in biochemical pathway, which is essential for our homeostasis, for example, diabetes and obesity. Okay, next. Okay, if we look at the global issue, both metabolopathies problem is something seriously become a global issue. If you look at the world map there, okay, so in Malaysia is one of the top problem in diabetes, and you can see from the graph we have increasing percentage of diabetic prevalence. You can see in for example, in 1986, we have only about 6.3% of diabetic with a problem in Malaysia, and then it keeps on increasing. In 2019, we have 18.3, about threefold. So this data actually is from National Health Mobility Survey in Malaysia. Okay, together with the obesity problem, again we have a problem. Is a alarming warning from our report. This report is from National Health Mobility Survey 2019. Again, Malaysia got problem with obesity. So if we look at what is the problem with obesity and diabetic to the male fertility. So next we go on to the next slide. Next slide. Okay, so you can see here, alongside rising obesity, diabetes, infertility issues have risen annually by 10 to 15%, with 50% of the cases involving male infertility problem. Okay, so both metabolic disorders significantly impact fertility, particularly in men, by altering hormone profiles, for example, testosterone or androgen hormone, and then it will affect sperm quality and overall reproduction function. Okay, so next. Okay, so this is also a global issue on male infertility problem. So if you look at the global issue in Western country, they start worry because 50% of the sperm produced by their population reducing at 50% level. For example, in 1972, we have 99 million per male, but then in 2011, we have only 47 million per male. So this is a signal that infertility is a big problem globally, especially in Western country and also in Asian country. So if we look at the Malaysian scale, also from our survey, 60% also have abnormal sperm morphology. Okay, so these factors actually comes from mainly from diabetic and obesity. Another word is metabolic disorder. So this metabolic disorder actually contribute to infertility via oxidative stress, reactive oxygen species, and then hormonal imbalance, and then it will impair reproductive and functioning, and it cause infertility. Okay, next. So as I said before, male fertility is dropping, across the globe. Okay, then next. Next slide. So we go on to the diabetes and male fertility issue. This is one of our focus research. Okay, again, then next, next slide. Okay. So as I mentioned before, diabetes is a metabolic disorder that characterized by hyperglycemia due to abnormal insulin production and secretion and resistance toward insulin. So that's that condition, hyperglycemic, will then suppress male fertility. And about 90% of male diabetic patients experience sexual dysfunction, impotence and infertility due to testicular failure associated with prolonged hyperglycemia. So that's why how diabetic male have a problem with fertility. Okay, next we go on to the summary of the effects of diabetes towards male reproductive function. Okay, so if you look at here, we have problem reducing in reproductive hormone, for example, testosterone. Okay, sexual desire decrease, as well as spermatogenesis or sperm count, and then will produce abnormal sperm. Okay, and then some of the protein that play an important role for fertility will become weak or become reduced or become low in expression of that protein in the testicular cell. Okay, next. We go on to the second problem of metabolic disorder. It's obesity. Okay, so with obesity, the same. Okay, next slide. Okay, so with obesity, it's a negatively affect male fertility by causing hormonal imbalance, oxidative stress, and reduced sperm quality. Next will be summary of the effects of obesity towards male fertility. Next. Okay, so obesity negatively affected by hormonal imbalance. Okay, reducing sexual drive, and then it will produce sperm with abnormality in terms of morphology, and it also create or increase the oxidative stress to the cell, especially to the testicular cell, and then it will cause erectile dysfunction or ED. Okay, so what is the current treatment to overcome or to address this issue? Obesity, diabetes, and male infertility. Next. Okay, so from this slide, you can see we have so many various strategies, to treat or to overcome problem of diabetes and obesity, and as well as male fertility. But the problem is with the commercial anti-diabetic drug, we have so many commercial anti-diabetic drugs like metformin or gabapentin, also insulin, but this treatment is ineffective in improving male reproductive health. Okay, so and then if we go on to the traditional medicine, for example, herbs, it exhibit anti-diabetic properties, but the problem, it may suppress male fertility. For example, peria, and then we have pegaga, and also with andrographis paniculata. So people who consume traditional herbs as ulam, so they need to be careful with the side effect towards fertility. Okay, of course, it's also we have to consider the dosage. Okay, and then also we have herbal product with a formulation ready, but the problem is lack of scientific evidence to support and give the efficacy of the safety of that product in the commercial. Okay, and then if we have we have also ART, it's assisted reproductive technology. This is a modern technology, but the problem with ART, it's expensive and costly, so it's accessible to individual with a high income. Okay, so that's why we're looking for the alternative medicine towards or to address problem with metabolopathy and male infertility problem. So the advantage of next slide of natural product or with our medicinal plant, first is natural resources, with a bioactive compound. For example, we have quercetin, we have astragalin, and so many active compounds that we have with therapeutic purposes. So it has antioxidant, anti-inflammatory, and hormone regulating agent. Okay, and then nowadays we have increasing interest for plant-based fertility enhancement. Okay, so traditional herbal remedies are garnering increased scientific interest for their potential in addressing male infertility issues, offering promising therapeutic avenue through their bioactive properties. So in our group in UKM, we have several potential plants that we study in our lab. So next slide, please. Next slide. Okay, so this is 6 potential plants that we study in our lab. So the first one is Lunasia amara. It's a local herbs in Indonesia. Local people know it's known as purwaceng. Okay, so and then we have Moringa oleifera or kelo, pokok kelo, and then we have Hibiscus subdarifa or roselle, and then we have Ficus carica ataupun pokok tin. We work on leaves and fruit part of plant. And then we have Genura procumbens, or local name is Sambung Nyawa. Okay, then we have Nigella sativa seeds, is Habatus sauda. Okay, so in this talk, I will focus on Moringa oleifera, which is highly important, and we have some promising results to improve or to addressing problem in diabetes and obesity, as well as male fertility problem. So all these herbs, we actually evaluated for improving sperm quality, and then we did DNA fragmentation assay to see the stability of DNA of the sperm, because sometimes we have good sperm with a physical characteristic normal, but they have problem with DNA stability. Okay, and then we also evaluate for oxidative stress. If this herb can improve this oxidative stress, and then supporting endocrine balance, meaning for andrologist hormone. For example, we have testosterone, FSH, and LH, and then we also evaluate for sperm proteomic. Okay, so next slide will be our subtopic B. This is on potential of Moringa oleifera as a metabolic regulator and male fertility enhancer. So basically, this is the objective of our research is to develop supplement that derive from Moringa oleifera, valued for its antioxidant properties, nutritional benefits, with aiming to improve metabolic as well as male reproductive health. Okay, so you can see the picture and the photos at the bottom. That is our dream to develop supplement with Moringa oleifera base. Okay, so next will be, okay, this is our main topic. The anti-diabetic effect and male fertility enhancer of Moringa oleifera aqueous extract. Okay, so next is I'm going to share the outcome of our research findings. Next slide will be our preclinical. Next slide. Okay, this is our preclinical study finding on Moringa oleifera non-standardized extract. This is aqueous extract to show the evidence of how this extract can control body weight of diabetic induced male rat. Okay, maybe I think I should explain a bit on the experimental design of this experiment. Yeah. So in this experiment, we have a rat as an animal model. Okay, and then we have quite a few group of animal. We have normal group, normal control groups, just a healthy group, rat, and then we have diabetic induced without treatment. This is a negative control group, and then we have positive control group. This is a metformin treated, okay, and then we have 3 different dosage of Moringa. With a different dosage, with a lower dose and then moderate and high dose. Okay, and then after about 30 days of treatment, then we sacrifice and then we analyze with a certain parameters. Okay, so we have share here. This is a body weight effect, and then we also have a good data on FBG. Fasting blood glucose level. Okay, so you can see the graph or the histogram at the right hand side. Significantly, Moringa oleifera reduce or control or improve the FBG level of diabetic and rat. Okay, if you compare to the metformin and also with the non-treated rat. Okay, then we have also preclinical study finding on the sperm quality. So next we go on to the reproductive parameter. Next. Okay, so this one regarding to the significant increase of sperm count. Okay, that arrow, red arrow to show the effects of Moringa extract to sperm count. Okay, if you compare to the negative and to the positive control. So our extract shown a promising result in terms of sperm count together with the sperm motility, the movement of the sperm. It's actively motile Okay, then we have next. This is sperm quality and testosterone level. Again, it showed a positive result in terms of viability. Okay, and with the testosterone level. Okay, always you compare with the positive and with the negative control. Okay, okay, next. Okay, with the testicular histology, this is just to show, how good of this extract in terms of spermatogenesis. Yeah, if you can see, there's abnormality and in terms of architectural of the spermatogenesis in tubule seminiferous. Okay, so and then if you look at the testis morphometric in terms of weight, and then in terms of diameter of seminiferous tubule, also MO treated gives a good result in terms of the weight and the seminiferous tubule diameter. Okay, so then we go on or moving on to the molecular level of this sperm quality evaluation. So we have sperm proteomic, because actually sperm proteomic is significantly important, because if we look at the just physical parameter, maybe we can see it's motile, it's with high viability and high in sperm count, but we don't know the status or the stability of DNA. Okay, so next slide on this sperm proteomic. So this sperm proteomic is study on the protein expression in the sperm cells. So this technology is offering insight into the motility, capacitation and acrosome reaction, and also fertilization mechanism. So with this protein profile, then we will know what is the protein involved or play an important role in motility, capacitation, acrosome reaction, and in fertilization mechanism. So in other words, this sperm proteomic strategies actually facilitates our understanding of fertility at molecular level. Okay, so next is okay, this is an image to show an evidence of Moringa oleifera extract towards sperm proteomic. Okay, if you can see in column, you can compare column number 3, okay, and column number 4. Okay, column number 3 is negative control. So and then column number 4 is MO treated. MO stands for Moringa oleifera. Yeah. So you can see there's some decreasing expression of protein. Yeah, from about 55 kilodalton to 9 kilodalton. So that is the protein affected by diabetic. Yeah. So and then when we look at MO treated, some of the protein become appear, and it's become highly expressed, with the help of our treatment MO extract. Okay, so and then when we do gene ontology with this LC-MS analysis, can you share the next slide? Is a sperm protein profile, obtained from LC-MS and gene ontology analysis. Okay, so you can see from blast to go and we go gene ontology analysis, we found that in a normal control we have only 24 a fertility protein which involved in fertility activity, but in MO treated we have 40 protein which involve or play an important role in fertility activity. Okay, and then when we look at this gene ontology, we found that this MO treated has 18 unique protein which are not exists or cannot be found in any other group except normal control. So let's look at what is the 18 unique protein that only present in our MO treated rat. Okay, next slide. Okay, so this is 18 unique protein from this MO treated group. So we cluster this protein into 4 different groups. Okay, so we have about 8 protein under spermatogenesis, meaning these 8 protein identified to be involved in spermatogenesis, in sperm production. Okay, and then next group is a protein that responds to testosterone production and testosterone activity. So it's protein number 10, 11, and 12. And then we have a protein group which involve in sperm ovum binding or sperm egg interaction during fertilization. So, and then we have the last group is a protein that involve or important role in embryo implantation. What we call it a basigene. Yeah. So we have we found the previous report. Yeah, this is an interesting part that basigene is actually a sperm factor that is play an important role for implantation. Yeah. Sometimes you can get the embryo but get problem with implantation. Okay, it's maybe the pregnant women will get abortion because of the sperm factor. Yeah, maybe it's they don't have a basigene on the sperm. I mean, in the protein, in the sperm protein. Okay, then we look at what is the bioactive compound that we believe, to contribute male fertility and also for metabolic to entertain the metabolic disorder. Okay, so next is just to show you, next slide. Okay, so these photos is I got from a previous report, to show that at the global scale, actually many researchers work on Moringa oleifera with a different part of plant. Some work on the leaves part of Moringa, and some of the researchers work on the pod, on the seeds, on the bark, and also from the roots of Moringa. So our team focusing on Moringa oleifera leaf part. So if you look at this slide, we have previous. Okay, we have a few candidates of bioactive compound which contribute to the effects of metabolic, to resolve the metabolic disorder, for anti-diabetic and also for anti-obesity effect, as well as for male fertility. For example, as I mentioned before, we have quercetin, we have astragalin, and we have camphorol and rutin. So in our team, we're focusing on astragalin as a compound to prepare our standardized extract. Okay, so next is our result. Okay, by using standardized Moringa oleifera extract. Okay, so this is data from from the lab to show that our extract we have this astragalin compound in our extract preparation. Okay, so you can see the peak of astragalin quite high in our extract. Okay, then we proceed with experimental design again. Next. Okay, so again we have a few animal group of that we test. We have normal and then we have control group, negative control group. positive control group, and 3 different dosage of Moringa oleifera with standardized extract. Okay, so again we can see the pattern of this dose-dependent manner of astragalin MO of our extract in sperm concentration. Okay, so next is data or preclinical study findings regarding to sperm DNA fragmentation index. Okay, so we see the status of fragmentation of DNA in the sperm. So again, we can see more sperm with fragmented DNA in diabetic negative control, meaning diabetic male rat without treatment. As you compare with MO treated, so we have most sperm cell with stable or unfragmented DNA. So you can, this thing actually indicate by the structure of halo in the sperm head. Okay. Next we have moving on to the subtopic number 2. B2 is Moringa oleifera effects on as anti-obesity and fertility enhancer. Okay, so next is our preclinical study findings, just to show you the effects of Moringa towards obesity and male fertility. So as you can see, Moringa again can stabilize or control the obesity by reducing LOI, Lee Obesity Index. Okay, so compared to previous slide, not ready yet. Okay, so and then if you look at the SOD, enzyme for the oxidative stress, so we have SOD at high concentration as you compare to the negative control. So, and then we have MDA. Okay, MDA also is an indicator of oxidative stress. Yeah, so MDA is quite high in the non-treated or negative control group compared to our treated MO. Okay, next is preclinical study findings to see the effects of Moringa, okay, towards reproductive parameter in obesity-induced male rats. So if you can see the histology of testis or tubule seminiferous, we can see in the non-treated diabetic, meaning diabetic without treatment. So we have so many cells in the tubule seminiferous with aberrant spermatogenesis. We have multinucleated of spermatogenic cell compared to the one with MO treated. Okay, so and then if you look at the morphometric parameter, so you can see the testis weight in MO treated, they are almost the same as the normal control group, as well as in the diameter of seminiferous tubule. Okay, again then we do this assay on SDFI, sperm, next slide, sperm DNA fragmentation assay. So quantitatively you can see with a negative, we have 41% of the sperm showed fragmented DNA, compared to MO treated only 11.3%. Okay, so the right hand side is just to show you the qualitative data. Maybe you can look at the halo structure of the sperm head. Okay, the bigger halo means the more stable of DNA content in their sperm head. Okay, so next slide is our key findings. So clearly we can conclude that this MO extract improve metabolopathy in terms of anti-diabetes and anti-obesity, which lead to fertility enhancement. So our first point is it has this anti-diabetes, anti-obesity, and then it enhances all the sperm parameters, for example, sperm count, motility, and normal morphology. And then number 3 is reduce oxidative stress, for example, SOD, MDA. And then also is decrease SDF or sperm DNA fragmentation index, and improve spermatogenesis. You can see the histology of testis just now. And then number 4 is it's improve testosterone level, FSH and LH. And then finally, we provide an evidence of molecular level, at protein level, that the proteomics support the biological efficacy of MO in male fertility. Okay, so our future direction, our team, next slide. Okay, so we are planning to proceed to clinical trial. Okay, so and then we try to expand our sperm proteomic profiling and investigating if there is any synergistic plan combination, maybe can boost up the result or the effects of Moringa oleifera. Okay, so next slide is my acknowledgement to our research members. Dr. Prof. Jamia, Prof. Wan Aizat, and then we have Dr. Rohaizat, Dr. Nurul Ain, and my PhD student, Minzo and Zahida Zahari. With that, thank you very much for your attention, and welcome to any question if there's a question from the floor. Thank you very much.
Okay, thank you, Prof. Hanem. It's kind of interesting topic. And for information, I also found in Malang, the research from our student in Malang City, in General Hospital, we found that mostly both male and female who suffered from diabetes mellitus and then hypertension and also obese, they have problem in fertility. Yeah, we are using IIEF, International Index of Erectile Function, and FSFI, Female Sexual Function Index. We found that there is decrease in both indicator for patients in Malang City who suffer from diabetes and also hypertension and also obesity. Yeah, so it's kind of opportunity to us to treat the patients with this kind of herbs. Okay, yeah. Okay. All right, audience, this is the summary of Professor Mahanim research in UKM about the dual benefits of Moringa oleifera from metabolic regulation to fertility. And we know Moringa oleifera contains so many active substances, majority is from flavonoids compound, astragalin, and this is benefit for regulation of metabolic imbalance, for obesity, because and it causes oxidative stress, hormonal imbalance, and impaired reproductive functions. And Moringa oleifera is useful for the disease, for the like obesity and also diabetes mellitus, but also increase the function of male fertility. Okay, now for the questions and answers, this is for you, the audience here, offline and also online. It's time for you to give the questions to Professor Mahanam. Okay, from biology students, okay. Please mention your name, and then the questions.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Can I introduction? I am a biology student Faculty of Mathematics and Natural Science, Universitas Islam Malang, and I member of team research Prof. Nur Athiroh.
Okay, that's great.
And I have question.
What's your name?
Naura Dinada.
Naura. Okay.
Radinada, Bu. The question is, for in vivo research, it also necessary to process ethical clearance in Malaysia. Apakah di Malaysia untuk riset in vivo-nya menggunakan ethical clearance juga? Sekian pertanyaan saya. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Naura. Yeah, Naura asking, is that in Malaysia also need the ethical clearance for in vivo study?
Okay. Thank you for your question, Saudari Nera. Naura. Yes, of course, we have to get the UKM-AEC. Yeah, UKM-AEC stands for UKM Animal Ethics Committee. Okay, so before we conduct an experiment regarding to animal handling, so we have to go through the UKM-AEC to get an approval. Then only you can conduct the experiment. Okay, so it's wajib lah, compulsory to have the UKM-AEC. And then to the person or any student who handle animal, they should have this short course, yeah, to have an experience handling animal. One day short course. Thank you.
Okay, yeah. So similar in Indonesia, we have the committee for the ethical clearance for the studies in vivo. Yeah, also.
And also this ethical approval is important for publication actually, yeah, yes. International publication. So they will ask you the code number of animal ethic approval. Otherwise, you cannot publish your paper.
Okay.
Okay.
Okay. We go to the next questions. Okay. Yeah.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Let me introduce myself. I'm Tania from Faculty of Mathematics and Natural Science. I want to ask about how to create an infertility mouse model atau model tikus infertilitas, bagaimana caranya.
Okay.
Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, very good question, yeah, from Tanya. Okay, so of course we have to suppress the fertility first, yeah, to see the effective.
Yeah, so many models to create the infertility in rat, right? Okay. Yeah, maybe from the online audience, from Zoom meeting, are there any questions? Okay, I guess there's no questions from the online audience. Okay, any more questions? Yeah, I guess what after you study using water extract of Moringa oleifera, right? Why you using water? Usually for flavonate compounds, using
alcohol.
Alcohol, methanol,
Yeah. Okay. So we have some specific reason, because we have a long-term objective. We have a planning, yeah, to to produce or to develop our finding into a product. So normally to produce in bulk, in mass production, so it's more economic if we use just aqueous extract or water extract. Yeah, that's why. But it's no problem if you start with the alcohol extraction just to see, just for the knowledge, our knowledge, what is the active compound, what is the effectiveness with the alcohol extract. But then in the long run, I think it is advisable to use water extract, because in the long term we are going to develop a product so that it's more economic with water extract.
Yeah. Did you find difficulties using water extract? It's very hard to get the astragalin.
No, because as I shared just now, we have quite a big peak of astragalin, so we have no problem with astragalin and aqueous extract.
Oh, okay, yeah, that's quite great to get the astragalin from water extract of Moringa aloe vera. Okay, I think this session we can end this session and go to the next session. And we are very grateful to Professor Mohanim delivering the topic about Moringa aloe vera for metabolic of male fertility, metabolopathis and male fertility. I think this research is very good, and we can continue. I think collaborations, maybe using, we have so much calorie, Moringa aloe vera, and the government use this for actually for stunting, for the children. We have so many problems with stunting, and also we use kelor for any purposes, in Indonesia, and also for daily consumption. We usually make this as vegetables. We call sayur asem. Using kelor, Moringa aloe vera. Okay. That's great. All right. Thank you for the attention and questions from the audience, both online and offline. I'm the moderator of this session. We are very grateful, and thank you for all. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. So thank you very much for Dr. Haja Erna Sulistiawati, who has guided and moderated the session. And of course, thank you very much to Prof. Mohanim. We are very honored to have you here as the keynote speaker for IC-BioTEStA 2025. Under your presentation of themes about the dual health benefits of Moringa aloe vera from metabolic regulations to fertility. Thank you very much. Once again, please kindly give the round of applause for this very outstanding keynote session by Prof. Mohanim. Thank you very much. Well, ladies and gentlemen, now we are moving on to the next keynote session, which is the second keynote session. Yes. And of course, these second keynote sessions will be presented by our presenters who has joined with us online in Zoom meeting. He is Professor Mulyoto Pangestu from Monash University, Australia. Okay, and of course, Prof. Mulyoto Pangestu will share his knowledge, his insight about innovating biodiversity conservation for a resilient and sustainable futures. And of course, these amazing keynote sessions will be covered in 40 minutes and will be moderated and guided by Ibu Ike Widyaningrum Evam. And she is a lecturer in Universitas Islam Malang. Please welcome her with a very big applause. Ibu Ike Widyaningrum Evam, time is yours.
Okay, thank you for
Ibu Fepti for the opportunity. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. And now we will move to the next session, which is the presentation will be delivered by Professor Mulyoto. Professor Mulyoto is an associate professor at Monash University, Australia, and a leading expert in reproductive technology, embryology, and reproductive biology. He is also an international recognized researcher and consultant with numerous publications in top-tier scientific journals. Professor Mulyoto graduated from Faculty of Animal Husbandry Jenderal Sudirman, University Purwokerto, Indonesia. Selamat pagi, Profesor Mulyoto. Apa kabar?
Alhamdulillah, assalamualaikum warahmatullahi wabarakatuh. Selamat siang ya kalau di sini.
Oh.
Ya.
Ya,
Sudah.
di sini belum duhur, Prof. Jadi selamat pagi. Baik. Postgraduate at the University of Melbourne and Monash University, and now work at Faculty of Medicine, Nursing and Health Science at Monash University as a lecturer at Education Program in Reproduction and Development, Department of Obstetric and Gynecology. Today, Professor Mulyoto will deliver a presentation about innovating biodiversity conservation for a resilient and sustainable future. The presentation will last approximately 40 minutes, followed by a question and answer session. Profesor Mulyoto, the floor is yours. Monggo, Prof, bisa dimulai.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. First, I would like to thank to the organizing committee for inviting me to give my presentation in this very prestigious seminar. When I got this invitation, I thought this was a bit surprised because the rector, Professor Junaidi, is my good friend. We did PhD together at Monash. Prof. Junaidi did in education, and I did my PhD in medicine. So, yeah. Can you see my presentation? Okay. So, my talks for innovating biodiversity conservation for resilient and sustainable future. Listen, this is very interesting topic for nowadays because as we know that we are living in the world where the world is from time to time is getting less and less productive. Except if we don't do any movement, any action, then by the time the world couldn't support us anymore. So if you look at this biodiversity, it's very obvious that this is the world which is supporting human being, like producing food, medication, raw materials like minings and everything. And on the other side, we have a human culture like religion, spiritual and everything. And then there's some other regulations set up by the government. So the mechanism of regulation set up by government, like making a regulation, don't build any building in the mountain area or near the river banks. And the culture, like some people believe, like the Hindus people don't eat beef, Muslim don't eat pork. So it's kind of like controlling population, controlling ecosystem. So if you bring closer between nature and human being, is the human being taking a lot from the nature, meanwhile, human being supposed to be returning or giving back to the nature so both sides can support each other. If we don't support each other, so there is like overexploitation, such as we were that in Java, in Indonesia particularly, most of land have been cleared and they converted into rice field. And the habitat loss, like we cut down the forest, cut down the tree. So as we now the population of animals become extinct in Java, and pollution, such as now since we do more deforestation in the world, in the area, so there is no lungs for the world. So if there is no lung for the world, so we can't get any clean air or fresh air for ourselves for breathing. Invasive species like learning from what's happening in Australia, many years back, European settlement brought in the rabbit into Australia. After a few years, they found out that the rabbits become a pest. Or buffalo, they brought in buffalo from Indonesia to Australia to work in sugarcane field, and then now they release the buffalo on the way in the wild, and now the buffalo damaging their farming area. And of course, the last one was the most popular now is climate change. Many years ago, we never know any La Nina or El Nino phenomena in the world, but then now everyone is saying La Nina, El Nino, and everything. So this became a big change in the world. Like when I was in Purwokerto around 1980s, every morning, every time I went to the university, I still wearing a thick jacket, and the fog everywhere. So the situation is very nice and cool. But then after I left Purwokerto, went to Australia and is coming back. So I found that even in the middle of the night, you need to turn on the air conditioner. This is a big change. So if you never go with somewhere else and then coming back, and then you never know what changes happen. Such as probably if you look at in Malang, around 70s, 80s, there is no air conditioning in the classroom. But now, every room, they must have an air conditioning. That's what the sign of climate change. So where we have that one is part of these situations come from us, a human being who living in the world, where we start exploiting the resources of in the environmental, then that's what's happened. So if you look at this one, we know that the world population is go far beyond the capability of food production and the area that can be used for farming. If you look at this one, the human population's gone almost exponentially, and then the food production there's some increase, but then the area that we use for farming or agriculture getting less and less. So in this situation, we know that we need to control human consumption. So look at this one, the illustration on the side, deforestation, they get a drought. In another season, they got a flood. And what's happened with the people living in the area, they experience famine, not enough food, and the food one increase, very expensive, and not everyone can afford it. So there are control that like a spiritual, religious, cultural values, like people, like I don't say like a tahyul or mythos that in Java, some people say don't go to that area because that area is very winged or something, so people never go to that area, means the area properly preserved and protected because no one touching that area. And recreation and ecotourism now become very popular because people start going to recreation area, ecotourism, so they start talking about how we going to this area, camping and everything, aesthetic appreciation. It is good to see something green, but sometimes the aesthetic become changed into something not sustainable, such as they built an aesthetic building, but they forgot to keep the environmental or the ecosystem surrounding the building. Now, the education and knowledge of the system. This is another part, another method to control how human minimize the damage or something of the environmental. By teaching how to eat properly in the teaching, by let the student or people how to eat in a moderate way, not excessive, recycle the rubbish and everything, and so they can have a good knowledge of the system, how they uh, how they recycle the rubbish. Like we know that Indonesia is very popular with the plastic pollutant, but we don't know how to get it off or make use of plastic. Many years ago, there's a quite big news on TV that country like Australia, New Zealand, they exported their plastic rubbish, and then they sell it to area in East Java near Surabaya, and they use that plastic as a fuel for cooking tofu. Yes, tofu is a healthy food, but then the way they cook tofu is using a plastic, which is when they burn the plastic, the fume of the plastic will toxic to the environmental. People working in the area can breathe the pollutant from the fume from the plastic burning and make them maybe not healthy. The sense of place and cultural heritage. Government tends to preserve the building, but unfortunately not all buildings being preserved properly. In Indonesia, especially in Java, there are many artifacts from the previous kingdom, but it's limited only for the temples and some other building, but not the area. The demand for housing makes the government or the public have to change the status from paddy field into housing, change status of forest into agriculture, etc. So the last of what list is the government regulation. Once the government put the regulation, like we know in Indonesia we have an IMB, izin mendirikan bangunan, it's supposed to be to help us to control the environment. But it's more on get permission from the neighbor without considering if we build this building in this area, what's happened with the water catchment? What's happened with the flood? What happened with something? And then we finish the building, down the track 2-3 years later, there's a big flood in the other area because we built a building here and then they block the waterways, and then the impact is flood. So not in the bigger area. So to avoid this one with an innovation. Innovation, as we know, there's something to change the way we do it. I mean, traditionally, we cook using wood. For instance, cooking, traditionally we find the wood, timber or branches from the wood, bring it home, use it for cooking in the kitchen. But then by innovation, they change from burning the firewood into making a stove. And then stove, we're still using fossil fuel stove. Then okay, now we change from kerosene into gas, and then gas now change into electricity. And then because electricity come from coal or diesel, then now we come with a new innovation is using solar as a source of electricity. But the need of integration or technology is we need to get a good approach to the community. For instance, if we try to bring in electricity, even though we use solar panel, and then one little kid get electrocuted, and then say, no, we're not using electricity at home because it's dangerous. My son touching the cable is got electrocuted, of course. So we need to educate them and make the wire safe and everything so it won't be any incident. And not just that, but we need to get the balance and ecological system, like if you're using fossil fuel, oil or diesel or petrol, then it may damage the environment. Socially, like some area, we can use cut the tree from the forest, but then if someone believes, no, you cannot cut the tree from that forest because it's dangerous, because the gene or whoever taking care of the forest going to be angry with us and going to punish us. And of course, don't forget, we need to get that economic resilience, because otherwise this technology delivered to us, but we cannot maintain, we cannot sustain to get technology running. Why? Because the cost to implement the technology is very expensive. For instance, we need to get a nice car, so we buy an expensive car. To run the car, we need to special petrol, maintenance, and everything. So this is no longer feasible or not getting any result for us. So it's a case study of fulfilling meat demand and consumption. So traditional farmers, like they own only like few cattle, few sheep, or few poultry at home, and then they need to feed the population. For the family, it might enough, but when we got a population like in East Java, more than 40 million, and if you look at how many cattle, how many sheep, how many poultry in East Java, how many milk production, then we may consider like, we need to import more. That's why Indonesia is very popular. Most people say, we're not importing any meat from overseas, we're not importing any rice from overseas, but in fact, we don't have enough land or agriculture land to raise the cattle, to raise the sheep, or to grow the paddy. In the meantime, people keep coming with a high number of consumption, like they eat everything. They might not control moderate eating, or because they're growing and they need it. And look, because more people eating, not enough supply, then we're talking availability, the price increase, people cannot afford it. So the risk is maybe one side people got good enough food, healthy food, or maybe some junk food but a lot, and the other side there are some people who can't afford to buy meals, then they become starving, famine, or now we call it stunting for the kids under 5 years old. So seeing the situation in this one, so that's where we need an innovation. I look at my case because my background is animal science, so the modern farming, like they're using machine, large capacity, either for cattle, sheep, or poultry, start introducing technology like precision farming, good feeding, health system, genetic engineering. They start using blockchain for marketing, like they go to slaughterhouse, they're not killing one by one, but they start using machine and everything. And those, if all working properly, and we see the how much demand, so it'll give like high supply for the product, the price getting cheaper, more affordable. Of course, they can be resilient and sustainable. Why? Because if people can afford to buy this product, and there is a supply system that support to get enough product, then we can easily find that yes, we can fulfill the requirement, we got enough, and maybe some excess or some what we call it extra production, and it will end up the healthy generation. Unfortunately, the government and the public haven't get into that condition yet. The government always try to fulfill the requirement, like make the price cheaper, but then somehow when they imported additional staple food or meat or anything from overseas, some people against, but unfortunately the price not getting cheaper anyway. So the challenge and risk, I mean, bringing something new into public or into community is not always smooth. Sometimes there is a problem, like when we bring in mechanization into agriculture system, then people start thinking, you bring the tractor into the field, then who could be working, digging or shoveling the soil? Some people say so. In fact, on the field, the farmers couldn't find any labor to help preparing the soil. So there must be something to avoid any inequality or access gap. So people understood that we bring in innovation. It doesn't mean we replace the human labor with a machine. Because people start talking about, hey, we don't have our unemployment rate is very high. Many people couldn't get the job, but what jobs they want? Like if we now go to rural area and we're asking the farmers, can you find anyone to plow or to prepare the soil for planting the rice? And they will say, no, we can't, because every young people tends to go to city working in the factory, so because more prestigious and everything. The risk of green wasting in finance-driven conservation, some country, not Indonesia yet, since they tends to preserve their environment, so they limit any development, any buildings and anything, because they want to keep the green area. Unfortunately, it's not always sustainable, except the country is very wealthy. So the country can stop from any future development or anything. But then I think we need to consider, make a balance between development and conservation. Economic trade-off versus long-term sustainability is another challenge for us, because most people tend to build a factory near the city. We learn from the case in Pantura. If you look at you passing through from Karawang or from Cirebon until Jakarta, you can see all the way is a paddy field or agricultural land. But once you pass Karawang, you won't see that anymore. What you see is factory, and factory. That area was well known as a paddy rice production center during a colonial era. But because to make it efficient during when Indonesia start going industrialization, they thought that easier to build a factory near the capital city, because all businesses gonna have a head office in Jakarta, and the government and other infrastructure. So they built the factory near Jakarta. So they ignored the role of Waduk Jatiluhur. So they changed from agricultural land into factory. Somehow, yes, this is good as an economic trade-off, but in the long run, the rice production's been declined, because the area that is supposed to be used for growing the rice, the paddy, now become a factory. So we need to find another place that suitable for growing the rice. Unfortunately, like many years ago, maybe some of you heard that the government during Suharto era tried to plant the rice in 1 million gambut area in Kalimantan, but this project is not working. And then this similar project was repeated again a few years ago, but they claim this not working. So not just this, so we need also the government understand, like as we know that now Indonesia is every district got their own regulation. So one district and the other, they may not always in line. So this bit tricky. So that's why the government need to be inclusive and contacting each other. So any regulation from one area gonna be in line with the other area or synchronized with the other area. Now, look at what is Unisma potential. I just look at Unisma, they got many faculties. Traditionally, they got Islam religious faculty, law faculty, agriculture, animal husbandry, engineering, science, education, economy, administration, and medical school. I'm not counting the magister or PhD, but if, say, Unisma as a pilot, They develop a integrated research site, because I'm from animal husbandry, soalnya pengembangan peternakan terpadu secara modern di tanah milik negara kecamatan XYZ or in Kabupaten XYZ untuk kebutuhan hewan kurban, penyediaan gizi bagi balita dan penduduk sekitar yang melibatkan murid sekolah ditinjau dari aspek bisnis, hukum, serta evaluasi kondisi kesehatan masyarakat setelah program berjalan selama 3 tahun, dan dapat dilihat dari aspek syariah, hukum, ekosistem, bisnis, administrasi, pemerintahan, kesehatan, dan gizi. It means the whole university will be involved in one project, one research project or extension, and this will be a good orchestra from Unisma, because every staff, every student, every academics from different faculty will talk each other, will work together, and showing to public that looks, we have our potential, we can work along together without saying that I'm from the faculty medicine, I'm not going to talk with anyone from faculty animal husbandry, from law school, we won't talk with from faculty of Islamic studies and everything. So make everyone sit together, develop a big project for Unisma, and we'll see the difference. Because what's happened in Indonesia now, every different, even not just within faculty, even within department and the faculty, there tends to be, this is my own, this is my own. So if we can put all together into one integrated academic activity, it will be nice. So in the conclusion, the innovation is not about technology. We need to consider the social impact of the technology itself. Look at how's the community, how's the impact after a few years. We cannot say like, okay, we got modern technology. Like when we introduced television many years ago, we can say that, yeah, this good way to get information. But then after many years, we can see the children stuck with television. So they might watching TV more than they study. Look at the relationship between people, nature, and economy, and collaboration between technology, indigenous wisdom. Like I believe that in Indonesia, some local community believe on something. Say, don't build the building more than 5 floors because you cannot have something taller than this building. Then, yeah, we cannot say this is something against the technology, but we need to know why they're doing this one for many, many years. If you're going to do scientific research, you can do so. And with this one, we can have a good resilience in economic, food production, and people development. So at the end, I would like to thank to Professor Judith Mistar, Director of Unisma, the organizing committee of IC-BioTEStA 2025, my colleagues, Associate Professor Seliket, Director of Education Program in Reproductive Development, and my colleagues Prof. Masyedi Sumaryadi and team at Laboratory Animal Reproduction, Faculty of Animal Husbandry, Jenderal Sudirman University. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the presentation from Professor Mulyoto Pangestu. As we know that we are as a human, we will always to utilize or to take advantage from the natural resource for a lot of things. Because I'm a pharmacist, Prof, I learned how to utilize the natural resource to be a drug, food supplement, or other. And we know that the environment condition will affect the active compound from the plant. So I think we need to strategy how to profit, how to always profit our needed without harming the environment. And from Professor Mulyoto presentation, I remember about drama Korea film about Blood Free. Blood Free tell about scientists who solve the environment and make a manufacturer to provide meat from cell, cultivate cell to produce meat. But that film is scientific fiction ya. Jadi Mungkin buat mahasiswa yang belum lihat bisa dilihat, jadi dia itu memang seorang peneliti yang sangat menyayangi lingkungannya. Dia juga berjuang gimana caranya memprovide kebutuhan manusia tanpa merusak, sehingga dia mengembangkannya itu dari sel. Dan sepertinya itu sangat topik yang baik ya untuk di kita, terutama dari biologi ini, untuk bisa mengembangkan penelitian-penelitiannya. And maybe first question from me, Prof. What are the main environmental challenges faced in applying biotechnology to food production, and how can they be addressed?
Thank you. So thanks for the nice question. I mean, that's become a big issue for the last few years, because when we implement biotechnology, sometimes we try to put all the best into one. Like if you watch the movie Twins, there's Arnold Schwarzenegger is a baby, and his mother was a beauty queen, and technically she was inseminated by semen from few different persons, like the scientist, the athlete, everyone. So one they born become twins. One is Arnold Schwarzenegger, the other one is Danny DeVito, the naughty one. So when we start doing this one, doing biotechnology, we need to know that it shouldn't affect the genetic and shouldn't have any sustained effect inside human body. As you aware that now many people reject the GMO, genetic modified organism, because some people believe that GMO food are been modified, and then if you consume the genetically modified vegetable or meat or anything, it may damage, like causing cancer and everything. There is always study to do this one. I know back in 50s, 60s, when there is no prior study to do experiment. Sorry, my cat. So people just do it, and as long as the production increase, they're happy. But now we need to look at the side effect of any plant or any treatment we plan to consume to the human being. So yes, I agree with you that the application of biotechnology need to be studied properly to avoid any side effect on the human generation in the future.
Okay, thank you, Professor Mulyoto. And then maybe from the audience. Okay. Microphone for Pak Hamdani.
Thank you. Let me introduce myself. My name is Hamdani. I'm from the Universitas of Islam Malang, Department of Biology. I have a question about this presentation from Prof. Mulyoto. How can we encourage active community participations in supporting biodiversity conservation program? So that's my question.
Thanks for the question. This is always an issue for everyone, try to do conservation, because often the people in the village, they say, I'm going to sell my land for the developer, because if I sell my land to developer, they're going to build house and developer coming. So this is kind of what they call it, difficult situation. Because one side, people need money. So the only way is by selling their land. On the other side, if they sell their land and the developer build the housing, we may look at, will this land gonna be feasible for the future as a house, or it will create another problem such as flood and everything. Not just that, sometimes we know that in the village area, people on a hill or anything with the trees, big trees, looks like a forest. So this need to be kept and maintained to what they call it, to keep the environment, to save the environmental. Once again, we need to have a good in the country, like in a good country, usually government will buy the land that if they want to buy land, so government will buy for the land. So developer cannot buy the land, but the government will buy it. So it's given income for incentive or income to the farmers. But in Indonesia, this hasn't happened yet. Most people tend to sell the land; they just sell it anyway. So even though like the government put regulation, don't build the house in this area, they change the bupati, change the wali kota, or change the governor, and then no, you can build whatever you like. So we need to be consistency in government, like from time to time, and then they know what the impact. For instance, like last time in the recent one in Puncak, the governor of West Java, they found out this amusement park was built in the water catchment area. It was approved by the previous governor. And now the new governor said, no, you cannot build this one. At the end, we found out that this amusement park was funded by the government money. So this kind of contradictory for the government itself, because they should know that this is their money, they built it, but this is like a big step for the new governor, because he decided to stop the development. I'm not sure whether it really stopped or just hold it for a while, but at least in the news they say, oh, we need to stop this development. So I agree with you, I understand your question. This is not just one person responsibility, but it includes like the government especially, and then the other stakeholder like the people living in the area, and university need to be able to involve in that process, such as give understanding what's the impact if, say, you build the housing area in this land, whether flooded in the next 5-10 years, or we need more field for rice or anything, land for grazing the animal, something like that. I know this is a complex for Indonesia, understand.
Okay. Thank you. And thank you for participate to the insightful conference, Profesor Mulyoto, because now in Indonesia is sudah masuk waktunya duhur, sudah mau azan. Okay, ladies and gentlemen, we have now reached in the end this session. On behalf of the organization committee, I would like to express our appreciation to Professor Mulyoto Pangestu for sharing his expertise and valuable insight. We also extend our thanks to all participants for your active engagement, and may today's session bring meaningful knowledge and inspire further collaboration. As we know that Unisma has a lot of fields, it means we can do the collaboration, research, or others. Once again, thank you, Professor Mulyoto. See you next time, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much, Ibu Ike Widya Ningrum, Magister of Farm, for moderating our second keynote presentation. Ladies and gentlemen, because we are now going to the next keynote presentation, the next keynote presentation will be delivered by Professor Annelie Petrisson from University of Lorraine, France. And Professor Annelie Petrisson already sent her keynote presentation with audio, video recorded presentation. And to assist this presentation, we would like to invite the moderator for this session, which will be moderated by Dr. Rio Risandiansa, PhD, and to assist with a Q&A session, we would like also to invite Mr. Ahmad Farouk Al-Hikami, Master of Science, to come forward. And without further ado, I would like to invite Dr. Rio Risandiansa to moderate the session today. Time is yours.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Okay. Good afternoon, everybody. My name is Rio Risandiansa. I am in charge of moderating today's speech by Dr. Anneli Patrisans. She unfortunately couldn't attend this meeting today, but she did send a presentation and a slide, which we will present to you. And if you have any questions, you could direct them to Dr. Farouk Al-Hikami, so to help with answering the questions. Now, Dr. Anneli is a professor from University of Lorraine in France, and her fields are around biomass, thermochemical modification of polymers, biopolymers, and also experimental and numerical investigation of coupled heat and mass transfer. Her presentation today is going to be on video, and it would be on the biodiversity for this conference. She would present a presentation entitled Innovative Approach to Thermal Wood Conversion for Sustainable Resources and Biodiversity Conservation. For the team, please, you can start playing the video that she would send to us. Thank you very much.
Dear colleagues, dear partners, let me express my gratitude for this kind invitation to make a presentation in the first International Conference on Biological Technology for Sustainable Nature. My presentation will talk about the innovative approach to thermal wood conversion for sustainable resource and biodiversity conservation. My name is Anneli Patrisans. I'm professor at the University of Lorraine in France and researcher in the Laboratory of Study and Research of Wood Material. I will situate my presentation in the context of current world concerns. I will introduce the paradox of progress, the necessity to build sustainable development. After, I will introduce some of our approaches, and I will finish with main findings and conclusions. Global challenges of our time are based on the paradox between the progress of technology and climate changes and biodiversity decline. Technological progress and development drive human advancement. However, they also accelerate climate disruption and biodiversity loss. This paradox highlights a critical tension. Innovation empowers, but also endangers our planet. Human activity changes in overwhelming Earth system. Our dominance over land and resources is reshaping Earth, raising risk for nature and humanity alike. The overexploitation of lands due to the agriculture, livestock, lodging, infrastructure nowadays occupy around 50% of habitable land. Fossil fuel overexploitation drive to carbon dioxide emission and resource depletion. Resources overexploitation like forest, fresh water, minerals, wildfire, they are exploited beyond renewable rates, leading to severe ecosystem degradation. Climate changes and global warming are one of the consequences. Each degree of temperature rise multiplies frequency and severity of heat waves, storms, wildfires, floods, and these phenomena are interconnected, driving cascading impact on ecosystems and societies. Here, in the first figure, we can see the interconnection between climate changes, society, and biodiversity decline. The second figure shows the shape of decline of biodiversity, but also proposes different scenarios of evolution of the biodiversity according to the human activity adopted. My presentation carries a positive message. We can turn the paradox into opportunity. Innovation can also be the key to restoring balance. Using green innovation means to develop renewable energy and eco-friendly materials. The circular economy means to reduce, reuse, and regenerate. Smart land use, combining technology and conservation and human ingenuity, can shift from exploitation to regeneration. Progress doesn't have to mean loss. If guided wisely, technology can help us to regenerate ecosystems, mitigate climate changes, and secure a sustainable future. Protecting climate and biodiversity means aligning nature, climate, and innovation. Bio-based materials and energy are the key levers for ecological transition and resilience. We can replace petrol-based materials with natural ones, using wood and bio-based materials for furniture and construction. We can also use wood for energy production, like renewable energy source, and lower the CO2 emissions. Now I will summarize the situation. In this figure, we can observe the evolution of the human population from the Neolithic, when started the human sedentarization, and the beginning of the agriculture. This period, the population of Earth accounts around 5 million persons. In the beginning of our era, the population number increases to 250 millions. In the beginning of the 19th century, with the development of the industrialization, the population strongly increases. This is like a direct here. And nowadays, this population is around 8.3 billions. Figure, I show again the increasing of the population, and here we can see also the increasing of the energy demand. In the beginning of the industrialization, beginning of the 19th century, one person consumes around 2,000 kilowatt hour for 1 year. Nowadays, this energy consumption is much more important at around 23,000 kilowatt hour per year. So we can see that not only the population increases, but also our way to consume the. And in this context, in increasing energy and material demand, it is really necessary to develop renewable material and renewable energy. In this context, wood can be a solution because wood is a source of renewable material and energy. To grow, tree is catching the carbon dioxide. producing material which can be used for the construction and to be burned to produce some energy. This way it releases carbon dioxide, and this carbon dioxide will be catched by the wood again. If wood is dying in the forest, it can be used also like fertilizer or releasing some carbon dioxide. Now we see that wood is a bio-based material reducing extraction of fossil and non-renewable resources. This is an indirect and powerful contribution to biodiversity conservation. Then we have green innovation, circular economy, smart use, and human ingenuity together. Now I will introduce our laboratory, the Laboratory of Study and Research on Wood Materials. Our laboratory is a multidisciplinary research laboratory. We have chemistry, mechanics, chemical engineering, and biology knowledges. We study the wood from all sides. The staff consists of around 40 academics and around 40 young researchers, PhD, postdoctoral, and invited researcher. All scientific skills are concerned, from the molecule, the smallest scale, to wooden structure, the biggest one. And our laboratory is interface between academic research and wood industry throughout the technology transfer centers. Used woody biomass has some advantages, like zero balance of carbon dioxide, minimal presence of sulfur, the reduction in the dependence of imported fuel, and the growing of employment in rural area. There is some drawbacks also, increased volume and high moisture content, whatever is the use. The dispersal and seasonal production of biomass, the difficulties in collecting, transporting, and storing the woody biomass, and the high equipment cost. If we focus on wood-like material, we can cite some shortcomings, like the weak natural durability, because wood is easily attacked by fungi and degraded. It has a low dimensional stability with important deformation, a hygroscopic character. Then we need to develop some preservation methods based on non-biocide alternatives. One of them is the heat treatment to upgrade the properties of the wood. In this method, wood is kept in inner atmosphere in hot media between 180 to 240 degrees, with an increasing of the temperature very slow, between 0.2 to 1 degree per minute, and wood is kept in this hot media for 8 to 12 hours to obtain a good durability for utilization like material in indoor, outdoor conditions, and also to have some luxury object. After use, this wood can be burned to produce energy without toxic release of toxic. The development of wood heat treatment in Europe started very early in the beginning of the 20th century and never stopped. Many industrial processes have been developed, and here we can cite also a French process, the process Plateau. Now I will focus on the upgraded torrefied wood for wood. The main industrial technology to produce heat-treated wood are the convective oven, where the inert media is smoke or steam, and the conductive oven working at the vacuum. Even if these processes are developed for years, there persist some obstacles to the industrial development. The homogeneity of the treatment is not achieved. The heat distribution in the furnace is not achieved. The control of the processing time to obtain the expected properties are not well known. and there is not a control parameter to guarantee the product quality. If the wood is poorly treated, customer returns are numerous and the business plan is failed. Scientific and industrial challenges of the processes are to identify a control parameter which can guarantee the quality of the final product. For the industrial process control, we need to study several wood species, study also the role of minerals in the biomass, potassium, magnesium, calcium, and also the treatment intensity, the temperature, and the residence time. With the collected data, we can build some kinetic of degradation and construct a predictive model which can help us to determine the residence time. And the application of all this study is to help industrials to well drive the industrial process for new bio. What is our experiment? Our research approach is very innovative. We use a semi-industrial scale reactor, and for difference with the other researchers which use frequently powders or chips, we use industrial scale boards with 60 centimeters of length and 70 centimeters of large. We can treat in this oven around 2 kilograms of material and follow the mass of this material for 1 gram of precision. For each board, we make a sampling to follow the thermodegradation of the wood material during the heat treatment. We analyze the changes of the chemical composition and the changes of chemical structure. We use elemental analysis to know the modification of the chemical composition, proximate analysis to know the moisture, volatile, fixed carbon and ash due to the treatment, XRD experience to know the crystallinity and the functional groups with FTI air, colorimetry to follow the color changes, and TGA, DTG like indirect methods to know the degradation of the main polymers, which are hemicellulose, cellulose, and lignin. For each sample, for each wood species, we follow the process with different treatment temperatures between 200 to 240 degrees. And we follow for different duration time the mass loss evolution and also the color evolution, and we try to make connection between the mass loss due to the degradation and the darkness of the color. And we also analyze the evolution of the durability of the samples. To know the durability, we put 3 heat-treated samples in the Petri and 1 wood natural sample, not treated, in contact in the fungi. And we keep all this system in conditions favorable for the development of the fungi, 20 degrees and 70% of relative humidity for 16 weeks. This is the protocol to know the fungi resistance. In the figure, we have present in the x-axis the mass loss due to the degradation, and the other axis we show the weight loss due to the degradation due to the fungi. So we can see that if the mass loss due to the thermodegradation is not very important, then fungi degrade the wood. When mass loss due to the thermodegradation is around 20 to 40%, then the durability is almost total. And this finding is obtained in our laboratory, and it can be used like control to guarantee the quality of the. What happened during the degradation? We obtained that during the degradation, the hemicelluloses, which is very sensitive for the temperature, are almost degraded. Celluloses start to be degraded also, and amorphous celluloses is almost degraded, increasing the crystallinity of the cellulose of the resulting wood bud. The lignin is strongly modified, and extractives are the first molecules leaving the wood sample during the treatment. So we try to analyze what is the factor to improve the durability, the dimensional stability. Is it connected to the color changes, and is the weakness of mechanical properties is not good for the constructions. In our laboratory, we led studies to understand why heat-treated wood has a good fungi resistance. We have emitted several hypotheses. One of them is the generation of toxic molecules during the heat treatment. So we extract the small molecules obtained during the thermal transformation of the wood, and we made impregnation of native wood with these extractives. However, this impregnated wood has been degraded by fungi. So this hypothesis had been rejected. The second one is the hydrophobic character of the heat-treated wood. But wood oven-dried is also hydrophobic, and this oven-dried wood is strongly degraded by fungi. So this is not the reason. The third one is the disappearance of the nutrient. But the fungi we use are degraded the lignin, and we saw that the lignin remains in the final sample. So this hypothesis has been rejected also. And the last one, this is the modification of the wood polymers. And recently, we observed that the small molecules produced by the degradation of the hemicelluloses and the cellulose condense on the lignin network, modifying this network. So fungi come to the heat-treated wood, cannot recognize the nutriment, and they cannot degrade this way. So this result has been published in several to model and simulate the degrading process. We use a very famous in the literature model, very simple model but very robust. This is the de Blasi model. In this model, the wood, the raw material, is considered like a homogeneous material, which degrades in the first stage, giving some volatiles, and a second stage, giving the final products and another volatiles. All the reactions of decomposition and creation are considered like first-order reactions, and they obey to the Arrhenius law. To identify the kinetic parameters of the model, we use the curves obtained experimentally, and giving the accuracy, we fit the curves of the model with the experimental curves. In this slide, we can see on both figures the comparison between the numerical results here with solid lines and experimental results with symbols for two wood species, the poplar and the fir. We can see that there is a very good accuracy between the numerical and experimental results, even if the model is simple. So for this oven, we can use the model of de Blasi, but if the oven changes, we need to identify the new parameters for the new oven to be achieved a good accuracy. This result, we can also simulate the composition of the final product, giving the degradation of hemicelluloses, cellulosis, and lignin, and report it on the figure. Yeah, I will finish my presentation, and thank you very much for your attention. See you soon.
Thank you very much for the presentation. Next is a question and answer. Please, if you have a question in the room, you can ask the question to Dr. Fana.
There are two questions for this theme. The first is there a specific certificate that ensures wood comes from forests managed sustainably? The first. And the second, how to ensure the use of wood in daily life doesn't disrupt sustainability. Currently, there are losses from excessive wood use, such as deforestation, environmental damage, climate change, and impacts on local communities. That's all. Thank you very much. Oh, I forget to introduce myself. My name is Ratna. I'm a lecturer from Biology Department. Thank you. Thank you for the time given to me.
Thank you. Yeah. Okay, Dr. Ria, so I answer directly the question. Yeah. Okay. My name is Farouk. I'm continuing the Q&A because Professor Anneli has some appointment. Okay, thank you for the question, Dr. Ratna. For the specific certificate from forests, I'm not sure if there is any specific certificate, as you mentioned. So I would like to answer the question for the second. Okay, Doctor. Yeah, so basically my research with Professor Anneli and also his postdoctoral students working on the wood and the specific wood, because in France, for the waste wood, they used to waste wood such as the bark. The wood bark is the skin of the wood. Yet if they need to like improve or monitor the wood quality, they need to remove the bark. So it's called bark, B-R-K. So the bark usually for the energy generations, mostly the research of the Professor Anneli, they use bark to produce the energy, right? And the other one is they select the wood based on the age. So for example, like in Indonesia, we also cut the wood based on, it's already mature wood, and then we cut it and we replanting the wood. So they do it like that. So once the age of the wood is mature enough, then they cut, but they need to plant. So the question is, the wood, how to proceed? So in France, as per our discussion previously, there are industry for the furniture, for example, like for home furniture, something like that. And the waste, for example, like sawdust, the sawdust is the serbuk gergaji, something like that. And the skin of the wood, they proceed as the energy. So for example, like the hydrogen generations or biofuel. Yeah, so they still balancing the sustainability based on the agriculture wise, and also they reduce the waste from the agriculture to produce energy. Yeah, that's I can answer for that question, Dr. Ratna. Okay. Yeah, thank you, Dr. Rio.
Okay, thank you. I believe there's a question from Prof. Hua, or no? No. Do you want to ask a question, Prof. Wang Lin?
Sorry? Oh, any question from the online?
Online, yes.
Online,
There might
yeah,
be
okay.
question from online.
Sure.
I think Prof. Wang Lin raised his hand. I don't think he can unmute, so wait. No, I'm not sure.
Okay, so it's okay?
Oh, yes, we can hear you now.
Okay, yeah, so great. Thanks for your sharing about your environmental conservation. And I'm from Taiwan, Kaohsiung Medical University, and my department contains two groups. One is for human medical, and another one is environmental medical. That means we want environment more healthy. And here, I just wondering, in the recently, they've been published in Science about carbon-2 plant. Yeah, so I just curious about in your countries, any genetic modification to rescue carbon dioxide level by modified plants. I just wondering if any project about this. Yeah. For example, we can enhance C4 or C2 carbon dioxide fixation. Yeah, so we can reduce carbon concentration in the atmosphere than to reduce carbon dioxide. I just wondering any plant scientists to do this job. Yeah, okay, thank you.
Thank you so much.
Thank you,
Yeah.
Professor. So, Dr. Farooq, if you can answer the question.
Sure.
Professor Wang Bin is asking if there's any genetic modification projects that you or Professor Annalie is currently doing regarding the carbon tubes.
Yeah,
please.
Thank you. Yes, thank you, Professor. So, yeah, it's a very interesting question that how the carbon nanotube and its modification to capture the CO2. Actually, we are also with Professor Annalie working on that kind of topics because the carbon nanotube itself can be synthesized from the wood. For example, like from the skin wood, like bark. So the recent project that because the bark itself contains minerals. For example, like potassium, calcium, or even silica. As the new research coming that all that minerals can be used as the adsorbent to capture the CO2. So in recent days, the CO2 capture can be done by two ways in most cases. The first one is the direct air capture. So definitely, basically, we capture the CO2 from the environment, from the atmosphere. And the second one is the post-combustion capture. So we basically make like a membrane to implement in that kind of, for example, like coal-fired power plant and something like that. In Professor Annalie's lab, so they for the current project, they still working on that the thermal science of the wood and also that implementation. The recent paper published from their project is they calculate the bioenergy and bioenergy of the kind of wood bark to produce the energy. And the present and the future working, I think it's possible. Yet, perfect. There is any projects in France for the making like carbon nanotube or another nanocarbon to capture. Yep.
Okay, thank you.
Thank you, Professor. Thank you, Doctor. So for now, this ends our session. The next session, I would return to the MC for the next steps. As for now, I would like to appreciate and thank for all your time and attention for this presentation. From me, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Dr. Rio Risan Diansyah. and also Dr. Ahmad Farouk Al-Hikami for assisting the keynote presentation from Professor Anneli Petrisans. Ladies and gentlemen, it is time for us to have a break, and we will continue again the next presentation from Professor Dr. Nur Athiroh, Professor Delfak Kosiandi, and Professor Bin Huang from Taiwan. And the last we will have Professor Dr. Miao Giao from London. We will have a break for about 60 minutes, for about 1 hour. So we will be back again at 1 p.m. 1 p.m. So I would like to invite all participants to come back again at 1 p.m. at 1 hour from now, 60 minutes from now, to have the next keynote presentation from Professor Dr. Nur Athiroh, Professor Delfak, and Professor Dr. Bin Huang in the afternoon session. Thank you so much, and see you again in our next session at 1 p.m. Western Indonesia time, Jakarta. Thank you. Good afternoon, and Assalamualaikum warahmatullahi wabarakatuh.
direct scavenging of ROS and flavonoid, potential to blood pressure reduction and antioxidant effect and improvement of endothelial function, reduce platelet reactivity, enzymatic modulation, anti-inflammatory effect, and the next became vascular protection. The next slide. Okay, here they are my fishbone, but was in very long-term research based on upstream process. The first observation, the result of observation is empirical. And in vitro test, the result of in vitro test, contractility artery decreasing. And the next in vivo test, the result of in vivo test, diminish oxidative stress and endothelial dysfunction. And this toxicology test become herbal safety. And the next clinical test, we are partner collaboration with industry and become downstream process and today commercialization. Here they are my fishbone AMA research. The next slide. Okay, ladies and gentlemen, this is my conclusion. There is no toxicity effect of MTM. And number two, there is no behavior abnormalities were observed of MTM. The third, no effect were found on oral exposure of MTM for 20 and 90 days compared to the control. That besides, no abnormality in histopathology in treatment. Number four, the result on this that MTM at antihypertension dose is safe even when taken for a longer period, and higher dose, this extract may have a potential to increase some hematological indices, but may induce tissue repair in the liver and heart. The lowest dose is safe for kidney tissue. And the next, the major findings from the present study investigated that MTM can modulate antioxidant endogen. Finally, it must be noted that effect of MTM preserve oxidative stress and safe for consumption. Ladies and gentlemen, declaration of interest. The authors declares that there is no conflict or interest regarding the publication of this article. The next slide. Acknowledgement, thanks to the Directorate for Research and Development, Society, Ministry of Research, Technology and Higher Education, Republic Indonesia, 2015 until now. On behalf of our team, I would like to express my deepest gratitude to everyone who contributed to the success of this project. Your cooperation and assistance have been available and our team research. The next slide. This is my documentation. I research with my student, my team in laboratorium. The next slide. This is preparation and laboratory with my team in laboratory. The next slide. The same preparation and laboratory. The next slide. Here they are. This is I have product the same of Norati. Norati is Norati. This is this one. Okay. This the next slide. Okay. Developing of comprehensive innovation. This is my innovation. Requires a long-term and continuous research process. Carried on since 1000 until its successful downstream application. This research has led to the creation of an innovation and holistic health product with significant potential in the health sector, specifically as an adjuvant health and wellness beverage enriched with antioxidants and proven to help maintain blood pressure stability. This formulation, branded as Norati, is the outcome of extensive research and has been developed in collaboration with industrial partner with PT DSM, PT Dua Sahabat. In minority, our minority have two certificate. Number one, home-based food industry, ARTP, in Indonesia, PART. The home-based food industry, known as Indonesia as industri rumah tangga pangan, refers to small-scale food processing enterprises operated at household level. These industries play a vital role in supporting local economies, enhancing food security, and promoting entrepreneurship with communities. And the number 2 certification form, Halal Certification Form BPCPH. The Halal certification issued by the Badan Penyelenggara Jaminan Produk Halal BCPH or the Halal Product Assurance Organizing Agency of Indonesia is an official guarantee that a product complies with Islamic dietary laws, halal, and is free from any prohibited haram substance or process. The next slide. This is a product testing from the research was conducted to evaluate its effectiveness with my partnership. And this slide. The next slide. The previous. Okay. Okay. During my outreach on the health benefits of FTM, the community responded with great enthusiasm and satisfaction. Many participants began consuming tea mistletoe and mango mistletoe as part of their healthy practices. Ladies and gentlemen, this is my research, and my research was dissemination with community. The next slide. This is my references. You can cite this in my Google Scholar or Scopus Index, please. The next slide. The next slide. Thank you. Jazakumullah khairan katsiran. Come back, moderator, Bu Ika, please.
Thank you, Professor Atiro. Give applause, big applause for Professor Atiro from Universitas Islam Malang. Thank you, Professor Atiro, for insightful presentation, and to be honored that I have an opportunity to be a little part from your journey research when Professor Atiro formulated capsule. I'm still remember. And we know that this research journey is not too short. But the interesting from Professor Atiro research is Professor Atiro make a parasitic plant to be valuable things that is utilized for our health, and they utilize a lot of part of red organ, ratus navergicus organ. Professor Atiro used a lot of part the organ from ratus navergicus in order, as we see from the presentation from Professor Atiro, that a lot of marker, a lot of part, a lot of data, and maybe we can continue. We are dosen-dosen muda maksudnya. we must continue the spirit from Professor Atiro. Alright, and we now discussion sessions, and maybe first question from me: how long Professor Atiro do the research until release product, and what is the challenges from the research journey?
Thank you, Ibu Ika. Bu Ika is my partner. Bu Ika is my leader to become capsule because Bu Ika is pharmacist, ahli farmasi, and have capsule from the mistletoe. My leader is Ibu Ika. Okay, thank you, Bu Ika.
I'm just help only.
My research since 2000 until now.
2000.
When I studied magister in Faculty Medicine Brawijaya University, the first I in vitro test, I make isolated organ with artery in ratus, and the result is decreasing contractility with artery artery rate 100. And the next period, in vivo test. And the next toxicity test. And the next clinical test. So I have a product based on the research is very long term for me.
So long, more than 20 years,
At least,
25, and until now still continue.
And this year I model diet.
The
previous experiment with anti-hypertensive model, and to 2025 research with my student diet models. Ratus diet model. So I have maybe Norati can decreasing body weight. So for the young woman, almost okay, Mr. Farouk can no obesitas like this diet. Inshallah, the result maybe analysis with Mr. Hamdani. Inshallah, the Norati can decreasing body weight in ratus.
Okay. Give applause again for Professor Atiro, and maybe continue again with the topic research about anti-aging. It is comprehensive.
This is my challenge.
From parasitic plants to be like from zero to hero.
I have a research with Mr. Bu Majida. What is this? Antioxidant cermai, Pilantus niruri, and delima. Can the next time can skincare? Maybe, inshallah. Okay.
So to be we are always young. Jadi kayak
inshallah.
Maybe for next research about anti-aging.
Researcher is 50% for me, and researcher 1% for me.
Okay. All right. Thank you, Professor Atero, for the answer and explanation from my questions. And then we will be continue with audience's questions. Please raise hand. All right. Okay. Mr. Farouk and Mr. Hamdani.
Mr. Farouk is a technique.
Mr. Imam, how much questions? 2, 3, 1, 2 only. All right, Mr. Farouk and Mr. Hamdani.
Mr. Farouk, the young researcher.
Thank you. Let me introduce myself. My name is Hamdani. What a insightful presentation from Prof. Atiro. This research has been going on for 20 years. Basically, at the same age as me, from a crying baby until today standing here as a researcher. Okay, I have a question for Prof. Atiro. Considering the significantly change in globulin, total protein, HDL, and LDL at the 1,000 milligram per kilogram body weight dose, what could be the underlying mechanisms?
Okay.
Yeah.
Thank you, Mr. Hamdani. Direct, I answer. Okay. Antioxidant can reduce cholesterol. Antioxidant, for example, quercetin, rutin is dominant in mistletoe. Also, mistletoe or amigo mistletoe can decreasing antioxidant, can decreasing reduce free radical. So become cholesterol is lower. So this is a role play of antioxidant in mistletoe and mango mistletoe combination. Like this. Thank you, Mr. Hamdani.
Okay, thank you for the answer, Professor Atira, and then continue with Mr. Faruk.
Okay, thank you for the opportunity, Dr. Ike. So, very insightful, Professor, about your research. I think flavonoid. So I do interest about the flavonoid because some of the flavonoid contain hydroxyl groups as our research, right? So my research also concerned about how hydroxyl groups could increase the energy content, such as if we mix with coal or being hydrogen generation. So my question is in mango leaf or mango mistletoe, right? Mistletoe is the penalu, right? Mango mistletoe. Mango and tea, okay. Yes. Is the flavonoid content a lot in that particular compound, or I could find another one? Because as I know that all the biomass, not most biomass, but as I know is containing flavonoid. So that's very good on hydrogen generation in my case. So if the flavonoid in mango mistletoe leaf is higher, more than another biomass, I think it's very good for improving the research from my topic. But so I need your maybe opinion about flavonoid in the mango leaf. Yeah.
Okay.
Thank
you, Mr. Faruk. Direct answer. Yes. Alhamdulillah, mango mistletoe more than flavonoid than tea mistletoe. Mango mistletoe then more flavonoid compared with tea mistletoe. So my product, the formulation 3:1, 3 mistletoe tea and 1 mango mistletoe, because the mango mistletoe is very higher antioxidant. For example, quercetin. This is, and mango mistletoe is very abundant in population. Probolinggo is create a mango. Always the mistletoe of mango is very abundant in Probolinggo and Madura and so on. Okay, mango mistletoe is more than tea mistletoe.
Thank you.
Maybe the next we have became research collaboration with technique with
sure.
Inshallah.
Yes,
okay.
inshallah.
Thank you,
Okay,
Mr. Faruk. Thank you, Ibu Ika. Okay, thank you, Professor Atira and Mr. Faruk. And of course, the conclusion from our conference or our meeting is always collaboration research or collaborations, another activity, and we can always make our university impactful to the society, government, or others. Because the questions is done. And all right, Professor Atira, thank you for your sharing such as an inspiring presentation. We also extend our thankful to the audience offline and online. Hopefully this decision will be bring meaningful knowledge. Once again, thank you and wassalamualaikum warahmatullahi wabarakatuh. Waalaikumsalam warahmatullahi wabarakatuh. Thank you. Okay, give applause again for Professor Atira.
Thank you so much, Professor Dr. Nur Atira. Bapak Ibu, ladies and gentlemen, we already finished the keynote presentation from Professor Dr. Nur Atira Abdul Shakur, and today we will have another 2 presenters. One is a keynote presentation from Kaohsiung Medical University, Taiwan, And we also have another presentations from King College London, will be presented by PhD candidate Mr. Callum Drysdale, a PhD candidate from King College London in the Department of Engineering as a biochemist, chemical engineering at Imperial College London. So we will have two presentations, but will be presented first by Professor Dr. Bin Huang from Kaohsiung Medical University, Taiwan, and then followed by another presentation from Callum Drysdale, PhD candidate from Biochemical Engineering at Imperial College London. To moderate the presentation, I would like to invite Mr. Dr. Ahmad Farouk Al-Hikami, Master of Science, to come forward and moderate the session for Professor Bin Huang, PhD, and Callum Drysdale, PhD candidate from King College London. Time is yours.
Okay, good afternoon, everybody. Good afternoon, Professor Huang. Right, yeah. It's nice honor to me to be a moderator of your afternoon session today, Professor Bin Huang. So my name is Farouk. Actually, I'm graduated from National Cheng Kung University in Taiwan, in Tainan. Yeah, we are very close. Yeah, Tainan to Kaohsiung, right? Okay. Before we start today's keynote address, I would like to a very short introduction of your profile, Professor Huang. So, for all the audience, Professor Bin Huang is the professor at Kaohsiung Medical University, Department of Biomedical Science and Environmental Biology. Professor Bin Huang holds PhD in Plant Sciences from National Taiwan University. It is the first top university in Taiwan. And his research field are including cardiovascular disease, system biology, and plant biology areas. And he also produced a lot of publications in good publications in quartile 1. And yeah, I think that's a short introduction to Professor Bin Huang. And in this today's sessions, Professor Bin Huang will deliver a topic about the mitochondrial transplantations in regulating gastric cancer malignancy. So, Professor Bin Huang, without further ado, the time is yours.
Okay, thank you. Yeah. So, yeah, good afternoon, everyone. Yeah. Selamat siang.
Yes, selamat
semua.
siang. Selamat siang, Professor.
Yeah. Okay, so I will begin my talk about the transplantation of mitochondrial modulates the malignancy of gastric cancer. Actually, I think everyone should understand, should know what the function of mitochondria. Everyone knows that mitochondria is a powerhouse in a cell. However, mitochondria can be transplanted between animals, including human. For example, we can isolate mitochondria from maybe from dog and then transplant into human, or maybe from frog or lizard and then transplant into human. So that's quite interesting topic. So in today's topic, I would like to introduce how to use mitochondrial transplantation to reduce gastric cancer malignancy. For example, we can use low efficient or high efficient mitochondria, maybe from different cell. Okay, then to modulate the cancer lifespan. Maybe for neuron cell, because we hope the neuron can be generated again, right? So maybe you can try to use high efficient mitochondria. As for cancer, you want to kill it. So maybe you can transfer low efficient mitochondria. Okay, so I think the whole world, this very gastric cancer is a big problem. Particularly high pressure. This world, because the world is developing, particularly for a lot of countries, they maybe have a lot of financial stress or some tension from work, right? So the gastric cancer, getting more worse whole world. Okay, so here, the age standardized incidence in Taiwan, we can see, 1 million person per year around country new case, it's around 1%. So the percentage is very high. Okay, so there also multiple risk factors, including food. For example, cigarette, or alcohol, or maybe a food too much or high fat diet, including instant food, something like that. And also HP, this bacteria currently regarded as the most serious problem in the world who induce gastric cancer. So once infected by this bacteria, then you must to use antibiotic therapies. Okay, so and another factor is inheritance. Okay, so as for therapeutic strategy, including surgery, radiation, and chemotherapy and immunotherapy, I think everyone should know this very well. But the mortality of gastric cancer remains very high. So even though immunotherapy or maybe CAR T cell, they already developed recently, and also a lot of technology company also a lot of budget focus on this therapy, but it remains maybe not satisfied. So we try to use mitochondria. Okay. Actually, in a gastric cancer, because we all focus on cancer characteristics. For example, they use glycolysis to produce pyruvate, and then pyruvate can enter mitochondria to do TCA cycle to produce a lot of energy. So this energy can be used by cancer, for metastasis or proliferation, something like that. Okay, so you can see here the proliferation, invasion, metastasis, and drug resistance all correlated to mitochondria. Okay, so the mitochondrial homeostasis, actually it means biogenesis. That means, the mitochondria can regenerate or maybe biogenesis, and then also its dynamic contains mitophagy. Okay, so this figure shows that a lot of proteins involved in this powerhouse, how the dynamic, how the variation in a cell. So it's quite interesting. Okay. And then endosymbiosis theory on mitochondrial transplantation, because as you know, mitochondria maybe in the ancient times, maybe billions years ago, mitochondria maybe an independent bacteria and independent individuals, then because they symbiosis with human animal cell, so they can coexist with human, okay, and beneficial to human cell, to their host, okay. So that's we call endosymbiosis theory, okay. So how the method of mitochondrial transplantation, it including natural transfer and also artificial transfer. Okay, so what is natural transfer? For example, in an organ, right? Organ maybe contains 2 or 3 cells. Once this cell is damaged, then it can call help from neighbor cell. Please help me, or rescue me, something like that. Okay, so how this cell can rescue this cell? Maybe they throw, or they transfer their good mitochondria into this damaged cell. Okay, this already published by a lot of articles, right? So the natural transfer, in a tissue, they can through tunnel nanotube, microvessel, or extrusion, internalized. Okay, and as for artificial transfer, we can use transplantation, this word. Okay, so we can co-incubation. That means you can isolate mitochondria from cell. Cell culture, maybe something like that. Okay, then this purified mitochondria you can incubate or inject into the target cell, so the target cell can be modified. Okay, so they also reported methodologies for artificial transplantation. Okay, so mitochondrial transplantation in treating cancer. In this study, we use gastric cancer as a model. So we harvest the normal cell mitochondria, and then to transfer into cancer cell, and then induce apoptosis and also reduce malignance and reduce chemo resistance. So this already been approved in breast cancer and melanoma. Okay. And also prostate cancer and ovarian cancer. You can see they are quite new articles. So here is a video show, but I think maybe this show doesn't work. So I also capture the image from this slideshow. In here we can see when we just add the mitochondria isolate from another cell. So we put into the medium, the culture tissue. Okay, so and then so you can time scale here, and then after a few minutes, so you can see this this cell turn a little green, right? Their endogenous mitochondria. That means this cell they have their self mitochondria, and then it's stamped by red color. And then the isolated mitochondria were labeled by green color. So after a few seconds, this mitochondria can be uptook by this cell. So this mitochondrial transplantation is okay and doable. Okay, so in this study, for mitochondria study first, you must make sure the mitochondria can be transplanted successfully. And here I would like to introduce our methodologies. Okay, so the first one, we will do mitochondrial membrane potential. This membrane potential also known as MP, and MP is an index to evaluate mitochondria membrane integrative. If membrane is okay, then the compress, all the compress can do some proton entrance. So we use this proton potential to evaluate the function of this mitochondria, or we can say efficiency. And then I think ATP level also important, to evaluate mitochondrial function, even though glycolysis also can generate ATP. However, mitochondria generate the most abundant ATP. So by these two indicators, you can know how about the mitochondrial condition between different cells. So then you can use, for example, we try to use this low efficient mitochondria from this GES1 cell. Then we want to reduce this cancer cell AGS, their mitochondrial function. So for the first, we isolate GS1 gastric epithelial cell mitochondria, and it used as a donor, then transplanted into mitochondrial recipient cell. That's a cancer cell. And actually not only AGS cell, but the other cancer cell, we also investigate there. Okay. And then mitochondria after isolation, so we have a kit, commercial kit, and we also develop a kit, they composed from sucrose. We can also isolate mitochondria. And then after co-incubation, you can co-incubation, for 24 hours. You can use it for recent microscope and for cytometry and ELISA, and also Wilson blot to know if the mitochondria already been transplanted into target cell. Okay. So in this one, you can see in after 24 hours, we can see here, the exogenous mitochondrial color, appeared. So that means the cell, the cancer cell already, transplanted by this mitochondria, right? So we can also, this is for recent microscope, and yes, for cytometry, we can also see the green peak shift. Okay, so it's already validated. And then how about transplantation? How about the function of cancer cell that been transplanted by low efficient mitochondria? That's important. That's point. Okay, so we can see after transplantation, we first evaluate, by when healing, to evaluate migration of cancer cell. So we can see after transfer, mitochondria, the malignance of cancer cell reduced. Okay. And also we use transwell to do invention assay. Similar to when healing assay, after mitochondrial transplantation, invasion ability also decreased, right? And then we also want to know, how about the EMT marker? And here I want to show, maybe because some student, audience, maybe student, right? Actually, EMT stands for epithelial and mesenchymal transfer. And for epithelial phenotype, that means the cancer cell will be more stable. As for mesenchymal cell, mesenchymal phenotype, that means that will be move on metastasis, very quickly, right? Okay, so in here, after transplanted with transplantation, with GS mitochondria, we can see this stable form increased. However, all the malignant marker all decreased. That's important. And the similar here. Okay, so then we can see the similar figure in here. Okay, and then how about the animal experiment? We can see after transplantation of mitochondria, the tumor size is very, very, very small. So if we use animal as like a culture medium, right? So with we seeding or inoculate, this cancer cell, the cancer cell without with, GS1 mitochondria. The result is quite different. Okay, so the tumor growth all decreased. Okay, so but this has already been published last year. Okay, so again, now we find a good niche, for to know mitochondrial transplantation can reduce malignance of cancer cells. So how about molecular mechanism? So we use proteomic approach, quantitative proteomic, and also metabolic approach. So in proteomic approach, we can see some signaling cascade were upregulated, but some were downregulated, and these proteins also, evaluated by Western blot. Okay, and then as for metabolic analysis, we can see the most metabolite identified in our experiment, or most focus on glycolysis and energy production. So that's quite interesting. That's fit to our expectation. Okay, so this is quite important figure. So we can conclude that after mitochondrial transplantation, this cancer cell, the lactate will decrease, right? And so this because cancer cell, they will accumulate and secrete a lot of lactate and accumulate a lot of lactate, in the outside of the cell, right? So in this study, we find lactate level decreased. So that means that maybe somehow stands for malignance is decreased, right? And here we know pyruvate accumulated. So, and also the TCA cycle, we can see isocitrate increased. So these two target, pyruvate and isocitrate, and moreover PP pentose phosphate pathway, these three key points, maybe very important. A mechanism of how transplanted mitochondria can reduce the cancer malignancy, maybe through this is three points. Okay, so a lot, and also here some general protein also monitored by Western blot. Okay. And then according to the accumulation of pyruvate in this cancer cell, so we also treat pyruvate directly. So you can see after pyruvate treatment, the migration is significantly decreased, right? So that means if you administration with some pyruvate food, maybe you can reduce cancer malignancy. But I think a lot of clinical trials need to be approved, in the future, in the next decades, a lot of decades, right? Okay, so I think the another interesting topic is the thinking is how about transplanted mitochondria competition with endogenous mitochondria, because you transfer mitochondria from isolated from another cell, so the mitochondria will to fight each other, right? I think that is quite interesting. Okay, so in this study we found we use some fluorescent dye, so we
Professor Wang, we lost your Zoom.
We found a very interesting event. Excuse me?
Okay. Now it's
okay?
Yeah. You can continue.
No, it's okay.
Yep.
Okay, so sorry. Okay, we also check mitophagy proteins and something like that, but it doesn't matter. The most important is mitochondria are more stable than cancer cell. So this uniquely observed in heterologous mitochondria. If we put autologous mitochondria, the similar result can be observed. So we use the second experiment. We check all these all this transplantation, but cancer cell mitochondria transfer back to cancer cell, the same cancer cell, and also we can see malignance increased, and then all the malignant marker EMT also increase, and the cell cycle also increase, something like that. Yeah. Okay. But interesting is this one. That's quite interesting. Exogenous mitochondria also more stable than endogenous mitochondria. That's quite interesting because both two mitochondria are from the same cell, right? So yeah, and we also changed the fluorescent dye. The similar result also observed. So yeah, in this study we use for cytometry, to know how the cell can recognize this mitochondria is mine or yours. How the cell can know the difference, right? So it's quite interesting. So we use it for cytometry to separate this mitochondria and to use mass spec strategy. So in conclusion, we find succeed this protein. Maybe they both are the exogenous mitochondria, and this to enable cancer cell to understand you are not my group and you are mine, so I will kill who will be killed, something like that. Okay, so this is quite important. For example, for gene therapy, stem cell therapy in the future, we can use this protein. We overexpress this protein, so we can replace the bad unhealthy mitochondria in the patient, because mitochondria is not good. So that's why he is a patient, right? So we can replace or renew his mitochondria. So it's quite interesting. Okay, so in a summary here, exogenous transparent mitochondria induce the distant endogenous mitochondria, right? Okay, so how to apply mitochondrial succession in clinical case? Just now I give a little hint about this. Okay, so excuse me, how long I have? Hello?
Yes, Professor.
Yeah, how long? Maybe 5 minutes?
Yes.
Oh, yeah, 5 minutes. Okay. I use 5 minutes to short introduce this also very interesting event, mitochondrial predation or hijack. Okay, according to this 2025, the cancer cell can transfer their mitochondria to T cell and then to treat T cell. So it's just like a PD-1 and PD-1 like immunotherapy, right? Okay, and also in the neuron, we know neuron can also, we can know neuron can also increase the cancer proliferation. So the demand of mitochondrial protein stem cell is quite interesting. So we use the culture system here, and we can see, cancer cell can predate or hijack, the mitochondria from neighbor cell. Okay, that's quite interesting. But if cancer cell have a more malignant cancer cell, they will also release the mitochondria to more malignant cancer. So this hijack is very interesting. Okay, then gastric cancer, they can predate low efficiency mitochondria. That's quite interesting. How come? And then I think we a lot of platform analyze the mitochondrial function. So here I just to show you, yeah, we have a lot of methodology and also platform, so we can have further cooperation. I think we will welcome everyone. Okay, so in the conclusion, and also biosensor enable mitochondrial transplantation and case can be modulated by transplanting low efficient mitochondria and mitochondrial dosage effect. Yeah, it can have a turnover rate succession, and then predation is worth studying for further regenerative medicine. Okay, so I would like to thank Dr. Lee from Internasional for my speaker support. Okay. And also about to company, yeah, for metabolic analysis, and here all my students in my lab. Okay, thanks for your listening and welcome to the most active city show. Okay, yeah.
Very interesting.
I can
yes,
stop
very
here.
interesting topics, Professor. So give a round of applause to Professor Bin Huang. Okay. Now it's time for Q&A series. So I'm open the questions and answer for the online first. Doctor, is there any from the online presenter? Okay. Now it's any questions actually. Yeah, from Dr. Ratna. So she's faculty members in Department of Biology. So. Yep. Okay. The second questions will be from the Professor Novi. Okay. The Dr. Rana, please. Time is yours.
Thank you very much for the time given to me. There are two questions. The first, can mitochondrial transplantation replace chemotherapy or serve as an adjuvant therapy accompanying chemotherapy? The second.
I see. Yeah. Okay. Please. Yeah.
The second, there is a suggestion has developed in the community that if someone is affected by cancer, fasting a lot can prevent cancer cells from proliferating vigorously. Is that all right?
Yeah.
Is it right?
Okay, thank you. Thank you for the question. Okay, Professor, you can directly answer the questions from Dr. Ratna.
Okay, for the first one is how mitochondria can be replaced. I think you mean replace chemotherapy?
Yep. Yes.
Okay. Yeah. Actually, I think in the future maybe it's a integrative therapy. Yeah. Maybe we can continue to use radiotherapy and chemotherapy, and also combine mitochondrial transplantation. Yeah. Okay. So I think. So far, I don't think mitochondrial transplantation can replace all the clinical therapy. Yeah, because it is too very novel. Yeah, so currently it just can be a distance, right? But I don't know. Maybe in the future, yeah. Because mitochondria are not only used in cancer therapy, but also in regenerative medicine. So in my lab, we also do use mitochondria to direct neural elongation. So I don't know what's going on in the future, but I with a very positive mind to see this. This mitochondrial transplantation. As for the second one is a patient or something.
Yeah, for the second, Dr. Ratna, someone affecting the cancer.
Fasting it can be reduce the proliferation
fasting,
of
no
cancer
eating,
cells.
right? Okay.
Fasting, puasa.
Fasting, okay.
Puasa. Can be reduce the proliferating cancer cells. That's right.
Fasting.
Okay, yeah.
Fasting.
Fasting, Professor, is like no eating during the time.
That's a good question. We also know as calorie restriction, right? Yeah, so maybe this already reported. They can activate the AMPK pathway. And then increase longevity after once you restrict your eating. So I think restrict food, is beneficial to mitochondrial function. But this is linked to correlated to cancer. Maybe I have no any idea about this, but I think food restriction currently is good. Okay. Do not eat too much.
That's a good suggestion to Professor Wang, that do not eat too much. Okay. And then the second question from Professor Novi. She is a professor from Department of Agriculture. Professor Novi, the screen is yours. Yes? We cannot hear you, Professor.
Okay, thank you
now it's okay,
for the moderator. Hello, Prof. Wang Bin.
Thank you.
Nice to meet you. I'm Novi. Actually, this topic is quite interesting for me. And probably some part of my question similar with Dr. Ratna. The first question is how far the mitochondria transplantation targeting an effective strategy for cancer therapy? I mean, how far to extent to which it has been used and cured, especially for the cancer. And then the second question is, as we know, mitochondria also contain DNA. Can in the future the side effect be predicted? Could they affect healthy cells for a long period with this therapy? Okay, I think only two questions, but thank you very much for the moderator for the opportunity to ask.
You're welcome, Professor Novi. Okay. Professor Wang, the first question is how far it has been used for curing cancer, the mitochondria, and the second one is mito contains DNA. What is side effect of this in the long period?
Okay. So currently, no any mitochondria application in clinical current. No. It just remain under experimental stage, and I know some in Taiwan, particularly in Taiwan. I think you know exosome, right? And some patients they inject exosome. Actually, exosome included. The biggest exosome in mitochondria. So some people want to have a skin care, so they will use mitochondria. But for cancer therapy, currently they only under clinical trial. Okay, not real application. As for the second question is about the side effect, and particularly because mitochondria have a DNA. Actually, in here we also use an immune cell to do immune response, inflammation response, and because mitochondria, the membrane proteins is just a little protein, particularly at the outer membrane. So currently we do not have any side effect in animal model. We ever inject IV, from through vein to inject mitochondria into lung cancer mouse and also liver cancer mouse, and no side effect observed.
Okay. Thank you, Professor Wang. So I think the time is up for this today's keynote address. Professor Wang, we sincerely thank you for your participation as the keynote speaker. Is there any one more questions left from the audience? No. Okay. I think it's enough for the time. Professor Wang, thank you. Thank you very much. Yes.
Okay.
Bye-bye. Yeah. Bye-bye. Yeah.
Bye-bye.
Okay, now we move into the final sessions of the keynote speaker. So, with Mr. Callum Drysdale. Yeah, is he on the screen already? Okay. So, hello, Mr. Callum. Okay, hello.
Hello.
Yeah,
Hello.
how are you? Okay.
I'm very well, thank you.
Okay, so I think it's early morning in the London, right?
Yeah, it
yeah.
is. It is.
Thank you for your time and participation. So, dear all the conference audience and all the faculty members, I would like to introduce our last speakers, Mr. Callum Drysdale. He is a PhD candidate at King's College London at the Department of Engineering, and he is a biochemist and also a chemical engineer at Imperial College London. So, Mr. Drysdale, my name is Farouk. I'm a lecturer in the Universitas Islam Malang, so I would be your moderator in this session. So, dear all the participants, Mr. Callum is a substitute of his supervisor, right? Yeah, Dr. Meguo. Is it correct, Mr. Callum?
I think she will be speaking later.
Okay.
I think I'm coming in an earlier slot.
Okay, okay. So I would like to, okay, then the topic today's session will be optimize axonic and microbiome bioprocess for waste to protein and biomanufacturing. Okay, so Mr. Callum, you have 35 minutes presentations and then 5 minutes for Q&A series. And the time is yours if you're ready. Okay.
Thank you. I will share my...
Yes.
Hello, everyone. Thank you very much for allowing me to speak here at this conference. I am very pleased to be here and to share what I've been working on. As has been said, that Dr. Miao Guo's lab works on bioprocess optimization for manufacturing. And as I'm sure many of you understand, the discovery in the field of biology can be a very slow and frustrating experience. I trained, as I said, as a biochemist, and so spent many, many hours with a pipette in my hand, moving very, very small quantities of liquid from one small vessel to another. And what has thus motivated this project of mine, which is the building of low-cost biological automation equipment, has been the motivation of freeing biologists and biology researchers from the tyranny of being locked into having to do lots and lots of very manual work, and allowing them instead to start thinking in both larger scale but also more theoretically. And I think we can see the benefits of this approach in that two recent Nobel Prizes have been won for large-scale search. So this is not theory-directed research. This is research that was the product of vast data sets that were accumulated over time and were achieved largely through either automation or just, as I said, search. And we biologists, we understand that there is a very high-dimensional search space that we need to cover to be able to provide any kind of comprehensive depiction or characterization of a biological system. So my system is aiming to my motivation for beginning and carrying on this project is about building equipment that will free biologists to be able to achieve this level of search in a way that is not extortionately expensive. Because I think this is a significant problem at the moment, is that large industrial or commercially available pieces of equipment are so expensive as to make often their purchasing not viable for researchers. Examples of this, such as the Tecan EVAN 2, which, whilst they are very multifunctional, are very expensive, costing hundreds of thousands of dollars, but also, and I think this is the sort of critical factor, is they are also difficult to use. Many researchers talk about the frustration of, I beg your pardon, of once they have purchased these pieces of equipment, the difficulty of setting them up and adapting them flexibly to new uses. So many researchers will say that once they've purchased it, they will then struggle with the limited APIs, the proprietary software, which makes accessing or controlling these pieces of equipment quite difficult. Particularly, I think we can add to this the fact that many biologists are not necessarily particularly technical, and they don't have the levels of code familiarity or hardware familiarity that would make dealing with these systems, these highly complicated systems, simpler. And much of this is understandable, because these are industrial companies, they're commercial, they're for profit. They want to, once you have purchased one of their pieces of equipment, you to buy other examples of their range. And that's how they keep customers tied into an ecosystem and keep customers buying from them. This, as I said, poses significant problems to the researcher, who typically is wanting to do multiple experiments, to flexibly adapt, and to be able to, in a less complicated way, use these pieces of equipment at a lower cost. Even some of these lower cost pieces of equipment, such as the Opentrons Flex, still can cost as much as $60,000. That's with all the pieces and all the bits that you often need. And this Opentrons was a company that was originally set up to provide this cheap liquid handling capability with the OT1 that I think originally retailed at around $5,000. But drawn by the possibilities, they've slowly increased in price, then at the OT2 and now at the Opentrons Flex. Furthermore, the connecting of these machines, such as the Opentrons, with an analytical piece of equipment typically requires things like robotic arms that also add higher complexity to this development process. Now, there are some open source alternatives, and I've put up two examples here, the Findus and the EvoBot. But typically these pieces of equipment struggle in that they're either not general enough, so the EvoBot was designed for a chemical or artificial cell generation or evolution and optimization system, and so is not necessarily general enough for a biological use case, despite it having other positive characteristics. Whilst the Findus robot above was actually we found when trying to recreate it, found numerous issues in the published information that made it very challenging to recreate and actually required a lot of redesign to actually make it usable. The other differences are the Findus does not have any form of plate gripping, so can't move plates around the work surface, whilst the EvoBot did, but it also didn't have any pipetting capability. So these were downsides of the existing models, both in their manufacturing and their capabilities. And so actually we decided that the thing that would actually be most beneficial would be to build our new system ourselves. So this is an image that you can see on the right of it, and I'll go more into the details, but the principles that we set out to achieve were as follows, and I will go through each of these because I think it's important and useful to discuss exactly why we set on these as important characteristics. So the high-level language, low-level control says that the user should be able to use a language like Python, but rather than just calling assays, they should be able to have low-level control. That means you should be able to say, move the head to an XY position, or move the Z position up and down. Because I think when you add greater complexity or add layers between the user and the control, this is a key source of frustration for users. Secondly is the low-cost materials. We aimed to do as much as possible with readily purchasable equipment without any complicated manufacturing. So that's a lot of 3D printing and commercially available motors and electronics, particularly if people who are unfamiliar with manufacturing and electronics want to try and build one of these themselves. The third principle we try to engage in is modular connections. This means that each module, so you're seeing one module there with the liquid handler, but we're also building others, it should be very easy to move plates and other samples between these modules. So rather than having to use liquid handlers, sorry, not liquid handlers, I beg your pardon, robotic arms, we want to make it very easy to put two modules next to each other and allow for ready exchange of materials between them. The fourth principle was proprioception, and this is the idea that the system should be aware of what it is doing and where its limbs and its different appendages are. And this, when you're using non-precision, non-high-grade equipment or motors and drivers, this is useful because it allows for self-correction. So it allows you to mitigate the downsides of using cheaper equipment, but also allows you to identify when errors have occurred. Because I think this is a big concern for biologists, is I might set this off and my experiment might take 2 days, and how frustrating it would be if after you come in on the second day and overnight an error has occurred, but you're unable to work out why that error has occurred. So you're unable to check and test. I mean that then the next time you run what is potentially a very expensive experiment, the same error will not occur. And finally, this principle that I think captures all of them is that we only need to be as accurate, be as accurate as we need to be. So don't pursue accuracy, and which leads to cost that is unnecessary. So you can achieve sub-millimeter precision, for example, on the movement, as we've done, but actually you don't need to go any further, and any further than that just adds cost without benefit. So I'll show you here a demonstration of our liquid handler. We're only using water here just for demonstration purposes. So what you saw there was the picking up of a plate, putting it down on a scale, a tip change, dispensing, and then moving of the plate into what will then be our plate reader. Oh, there we go. So I'll walk you through the different components and the parts and the practice and the thoughts that went behind them. So we start with the pipette, and this is the sort of one of the most important parts of building a liquid handling system, as accuracy and precision are vital. So this is built to be a P1000, and it's powered simply by a syringe pump, as you can see down on the left. So this is a single motor that drives a lead screw, that is a threaded rod, that moves a carriage up and down the way, which then opens and closes a syringe. Now these can be bought online or from suppliers for as much as $3,000 US, but we were able to build it for $90 with 3D printed parts and commercially available equipment. And we're able to meet the ISO standard here, so down to 100 microliters. This is a P1000 pipette. We're able to get CV values at the level of a commercially available pipette. At below 100 microliters, our performance degrades, but that's because we're using large tips and a large syringe. So this is quite easy to adapt for a smaller syringe. And this is an example of how much you can achieve when you build the hardware yourself and actually don't take for granted the complexity of the equipment provided by commercial providers. Then I'll talk about the gantry. So this is a simple XY system where you have a motor that turns a belt, which then turns, if I can show you, you can see my mouse, turns a pulley that moves the carriage up and down. So because this is a simple XY system, it's not as sophisticated as some 3D printers, the highest grade of 3D printer, but it is used by some 3D printers, and as they have to require get sub-millimeter precision, we felt this was appropriate, and as a result it has been, and we've seen very promising results with no issues of drift or calibration issues. Then we've used the scale. So the scale, I'm not sure if you saw, we placed the plate on it, and this uses a load cell to measure the mass dispensed on top of it. And this is part of our proprioception, in that not only are you aspirating in a volumetric way, using the calibrated steps on the syringe pump, but you're also able to confirm the accuracy of your dispensing using this system. So by providing this always two-level verification of the level of liquid, we're able to ensure that you're always achieving accurate and precise dispensing. And this is key to giving researchers confidence that this is a piece of equipment that they can use. We are still building 3 other pieces of equipment. So this is a temperature-controlled incubator that has 4 slots that can slide out and hold plates, a plate reader, so that was what you saw the plate be put into in the demonstration, and this is a 96 well plate reader that can do single wavelength OD measurements, and a bioreactor that can act as a source of microbes or microorganisms during growth assays. So this is our first plan, is to do large-scale growth assays for experiments that I'm working on in my PhD. So these examples are, I'm studying cellular economics and the ways that cells maintain internal Bayesian models of the likelihood of transitions between different states. So I'll be measuring that by perturbing the environment that the cells are in, and trying to get back to the models that the cells have for their environment, and this is for bioprocess optimization and performance in bioreactors. Then some of the other experiments that people have suggested to us that would benefit from a large-scale automated and sort of self-driving system are microbial sensitivity studies. That would be testing the response of multiple cells to, say, antibiotics or stressors, in order to, in microbial communities or multi-organism fermentations, able to maintain consistent ratios between organisms. And finally then, examples such as the directed evolution of cells. But actually, I would welcome suggestions and people reaching out, because it would be a shame, we feel, if the hardware was not fully utilized. And in fact, the more people that could think of use cases for it that would benefit from large-scale automation, the better, and I think the more beneficial this equipment will be. And I would stress that I would encourage people, even if they think that the use case that they have would require a bit more equipment, to still contact me, because in fact we found that many of these pieces of equipment, even analytical pieces of equipment, can be built in a month or two. There are two of us working together. That actually these are less complicated than they are first made out to be, and that actually we can achieve greater research throughput using this method. I think the key learnings that I'd like to pass on to people are that modern LLMs make gaining skills outside of your area of expertise much easier. So as I said, I trained as a biochemist, and then did a master's degree in chemical engineering, but this was largely in mathematics and optimization. But actually, using LLMs, I've been able to gain mechanical and electrical engineering understanding that has allowed me to build these systems, and that actually I would encourage people and researchers to think not simply of themselves as people who purchase equipment, but rather actually as people who can build it. And I would say that many of the great scientists who inspire me, people like Sanger or Newton or Hooke, were not just scientists, but they also pushed the bounds of hardware by building it themselves. And by building things that previously didn't exist, they were able to find things that were previously unknown. And I think those two things come in parallel. And finally, that by increasing the scale of data collection in our modern age of AI and large machine learning, we can find insights that might be hard for a purely theoretical and more precise experimental method would be able to identify. Thank you all very much for listening. If you would like to contact me, here's my email address, and I'd like to thank Dr. Miao-Go for her support, and invite anyone to raise any questions or things that they felt I could explain more. Thank you.
Thank you so much, Mr. Kalum Dristil. Okay, it's very interesting sharings today, and I'm a bit curious, Mr., because about so this is the Q&A series. The time is for question and answer. But before we start, I would like to ask a little bit, because I'm from mechanical engineering, Kalum, from University of Islam Malang. So I'm interested in your setup in terms of the machines, like the packing and the pipetting, like the automations and something like that. Because you're working as the biomanufacturing, I mean the biologist and also chemical engineer. In biomanufacturing, as you introduce and as your, all the production of machine, are the boundaries, all the boundaries why you produce by yourself and then production of the automation, is there any specific purpose of the particular tool system you produce, packing, pipetting, compared to the commercial one? When you compare is there any boundaries, considerations from your machine, for example, like load cells and others machine, like you showing us the video, it was nice. Compared to commercial one, why do you manufacture by yourself? Is there any specific purpose on it?
So the reason we manufacture ourselves is is because the cost of doing it ourselves is up to 2 or sometimes even 3 orders of magnitude lower.
Okay.
And in addition, by designing it yourself, you can design systems that are adapted purely for your own use case. And you can also have full software and hardware control. So when you require modifications, they are simple to make, and there's no worry about voiding any warranties or damaging it, because you fully understand the system yourself. You are able to convert or redesign or update or improve any system that you actually require. So it allows researchers who don't have the funds to be able to buy one of these very, very large pieces of equipment, or the expertise to integrate multiple complicated pieces of equipment to achieve this level of automation that would be beyond anyone currently without significant financial resources.
Okay, so yeah, I think it's I really agree, because as I also feelings that all the equipment for the research, especially for the biomanufacturing, it's really high expensive, and it is really a good idea to produce by ourselves, so we understand more about the system, and we also can be adding another system that we want. Okay, so all the participants, we open for question and answer. So if there are any questions from the online presenters and also offline participants, please. We will come 2 or 3 questions today. Okay. I think it's sufficient for today's talking, Callum Drysdale. So good luck for your PhD in King's College London. So keep in touch with us in the future conference and also some guest lectures. Okay, thank you for your time. Thank you. We sincere gratitude for your contributions as the keynote speakers today. Okay.
Thank you very much.
Good morning in London. Okay. Bye bye. Yeah. Okay. So all the participants in the international conference. So this is the end of the keynote speakers today, and I would like to give this next agenda to the Master of Ceremony.
Thank you so much, Mr. Farouk Al-Hikami, for moderating the session. It's a very, very informative keynote and presentation today from the bioengineering perspective. We have received many information about the state of the art in the area of bioengineering and many interesting topics that we have discovered today. Ladies and gentlemen, this afternoon at 3 p.m., the schedule is actually with our last keynote presentation with Dr. Miao Guo, but we are still checking the Zoom meeting, whether Dr. Guo has joined our meeting or not. Dr. Guo is in the room. Ladies and gentlemen, while waiting for the last keynote presentations, we are still giving the time for the IT team to arrange the breakout room to process the breakout room session. And I would like to invite Dr. Ahmad Farouk Al-Hikami again to moderate the session. We will have Dr. Miao Guo, sorry if I'm mistakenly pronounced your name. She is from the King College London, and to moderate the session we have Dr. Ahmad Farouk Al-Hikami. And today, because Column already presented his presentation, so we'll have last keynote presentation from Dr. Miao Guo. To moderate the session, I would like to invite Dr. Ahmad Farouk Al-Hikami to moderate the session. Time is yours.
Okay. Hello, Dr. Guo, Professor Guo. Can you hear my voice? I think you are muted. Your voice is muted.
Yeah.
Okay, now it's clear. Yeah. Good morning, early morning in London, Dr. Guo.
Hi, good morning.
Yeah, hi.
Hi.
Okay. Dr. Guo, thank you for your participant as the keynote speaker today. I will be your moderator for this study session. Before we begin, I would like to introduce a short biography of the Professor Miao Guo to all the participants. Professor Miao Guo, she is an associate professor in the Department of Engineering, King's College London. She leads the Biorenewable Lab, and also she holds a PhD in Life Science from Imperial College London. And Dr. Guo's research is, she published a lot of papers in the field of life cycle sustainability, waste to resource technologies, bioprocess, and process system engineering. Without further ado, I would like to warmly welcome Professor Guo for the presentation today. The professor, the screen is yours.
Thank you. Okay, I'll try to share my screen, and yeah, wait, buy me a second. Which I'm not sure which screen you can see.
Okay. Maybe the operator pick the Dr. Guo as the co-host. Already.
Yep.
So, Professor Guo, you can share the screen.
Can you buy me a second?
Sure. Yeah.
Okay. Can you see the screen?
Yeah. Waiting. Yeah. Now it's clear. Yeah.
Okay. So buy me a second. I'll go back to the beginning. Okay. All right. So how about this?
Can you make it full screen?
Yeah, it is already full screen.
It is full screen already. Okay.
Can you see which screen you can see? I'm not sure. It's a full screen or stop sharing?
I don't think so because there's still.
How about now?
Now it's perfect. Yep.
Okay, excellent. So you can see the full screen. I can't see you because I'm sharing the screen. Yeah, please. Yeah, can you see the full screen?
Sure.
All right.
Yep, already.
All right. Hi, good morning, everyone. It's my great pleasure to be here presenting our research. Well, thanks first of all to give this opportunity to share our work at King's College London. So as you have seen on the right lower corner, that's basically the King's College London. We have 5 campuses, Guest Campus, Strand, Waterloo, and Denmark Hill, and St. Thomas Hospital. And Denmark Hill, St. Thomas Hospital, and Guest Hospital are mainly like a home for medical research. And Waterloo is a home for biological medical research, while Strand is a major campus where engineering department is located. So we, at Strand, is a home for multiple disciplinaries, including engineering, physics, and also other, informatics, mathematics, and so on. So I just want to give you, before I start, I would like to, introduce also King's College London. Today I would like to share our research about how to optimize basically bioprocess, which is either underpinned by monoculture or microbiome to convert the waste to microbial protein and also wider biomanufacturing. So before we start, we probably would like to think why it's very important to basically consider what is the current bioproducts landscape. So if we look at the current bioproducts, it's either primarily utilize the carbon derived from the food crops or the nitrogen derived from the very energy-intensive Haber-Bosch process. If you look at the right lower corner, this nitrogen cycle, globally 145 megaton of nitrogen is fixed through either biological or Haber-Bosch process. And out of this, over basically 80% of it has been released back to environment, either through atmosphere or water emissions. Only small proportion, less than 20%, ended on fixed as a relay food. So here we started to pose a question, whether and how could we actually, develop new technology to reduce the cost, but also improve the sustainability of the alternative protein and material. So the question is whether we could find alternative carbon and nitrogen feedstocks. And we started this learning journey together with lab members, Mason here and Nippon. And before we start, we also try to quantify the different waste streams across the UK. And this diagram on your left-hand side gives you an overview of the different waste streams in the UK. And that's including, we focus on the, let's say, the contaminant-free waste stream derived from mainly food and drink industry. And the blue part shows the waste at the factory gate, and the orange part shows all this waste across the whole supply chain. So you can see across the different waste drink and even dairy waste and food waste. And now surprisingly, like a large quantity of the nutrient and carbon has been wasted. We often call it waste, but not necessary. It potentially can be recovered. So this quantitative value actually is consistent with the global picture. Globally, over 1/3 of the food is wasted across the whole supply chain. So all these rich, carbon-rich, nutrient-rich streams can be potentially converted to the bioproducts such as bioplastic, biofuel, high-value molecules, and also protein, etc. Here, we focus on the bioprocess convert this waste to microbial protein, either for animal feed or for human food. And before we start, we also look at, in addition to the food and drink industry waste, we're also interested in the solid part, which is lignocellulosic material. So give you a sense what is lignocellulosic. So cellulose, as the most abundant naturally occurring molecules, actually is really widely distributed across the globe, across the different continents, as you can see from the diagram. So that includes essentially the agricultural residues and also all the range of forestry and so on. So here we try to capture in particular agricultural residues and see how this agricultural residue in terms of molecules level as cellulose, hemicellulose, how is the potential to be converted to the formable carbon and to be utilized further. And if we're looking at, of course, the distribution across the globe really vary across the different continents. But if we take the big picture and through the circuit diagram, we can see globally over 11,000 megaton of lignocellulosic material is generated. And all this lignocellulosic waste, if we take that route as a potential here, as a potential, microbial protein, for example, using the food-grade microbial strains like Fusaramina natum, that could be converted as over 560 megaton microbial protein per year. So what that means, that could really feed global population to meet the protein demand, which is really striking. And based on this baseline, we also use the machine learning method, and to, as shown on the right lower corner of your screen, we basically predicted how the lignocellulosic material from the 5 stable food crops would look like over the next 4 or 5 decades. And that further can be translated into the edible protein alternatives derived from such a waste stream, which is really interesting. So that shows, well, all this new potential protein can meet our future demands, especially considering current protein deficiency and also a land-intensive protein landscape, particularly, derived from the animal products. So, very much inspired by this, we started looking at high-throughput method to basically couple this microplate, like many techniques, like a microplate technique, and as well as analytical chemistry. As shown on this, visualized in this diagram, we look at a range of solid liquid phase of the waste carbon source, and further through the initial basically incubation, and also develop this inoculation and inoculate in these microbial reactors, and then further through the microplate reader and to correlate optical density with a cell drivet, and then we sample this the liquid phase, which essentially analyze the fingerprint of the molecules, and through colorimetric method or liquid chromatography. Of course, here we focus on targeted analysis and to try to track how the substrate would deplete along the time, and to understand the cell growth pattern as well as in response to also the substrate utilization pattern. And all this rich data allowing us to further develop, predictive kinetic model to predict the cell growth, basically performance, behavior, as well as the bioprocess. And why this high throughput method? First of all, it offers a bit more sustainable option because it utilizes a minimal amount of waste, the chemicals, but also allowing us to do rapid screening, but also highly scalable and offer the high reproducibility. And of course, that offers offers the potential for future automation and also for self-driving lab. So here, I would like to share a few slides just to highlight what we have found through the journey and to understand how is a waste substrate derived like the microbial protein. What we focus a range of single particular sugar, and you can see here the monosaccharides, which is the globally most abundant monosaccharides like glucose and fructose, but also we focus on the dual substrate, but as well as the complex real-world waste, such as the waste functional drink, which is derived from the fruit and the vegetables, the functional drink. So here the results are going to be shown in the next couple of slides. We basically explored the fungal cell response we used a strain called fusamine-anatom A35, which is a strain known for the corn, which is food safe. So we mainly, through the screening, we work with generally recognized safe strains, also called grass strains. Well, I hope this diagram on your left-hand side shows the biomass growth pattern, and the right-hand side shows the different substrate utilization, like a depletion along the, all this time course experiment. And this monosaccharides utilized by fusamine-anatom A35, as I mentioned before. So this summarizes really all the patterns as we observed an initial lag phase prior to this exponential growth, comparable across all the substrate, well, except for this pink line, which is galactose. And this shows a really, galactose growth shows a remarkable much longer lag phase. This suggests for glucose, fructose, and xylose, this core metabolic pathways required for growth is induced relatively quite quickly. But in contrast, this galactose and potential lactose also acquire additional regulatory activation or pathway induction before this assimilation can take place. So the major differences between the substrate were observed in the rates of the substrate utilization and, of course, the exponential growth rate as well as associated biomass yield. So on the right-hand side, as you can see, the glucose depleted quite quickly, consistent with its role as the preferred carbon source, and of course, with the presence of the high affinity glucose transport system. So if we instead looking at the xylose, which is the red line, so the xylose utilization proceeded at a slightly slower rate than glucose, but ultimately achieved quite high biomass yield. This suggests once the xylose assimilation pathway is fully active, the carbon flux can be directed more efficiently toward biomass production, or say protein production, although a lower rate of substrate turnover. In addition to this fructose, we also did a fructose, and fructose showed although a slightly slower utilization rate compared with glucose and xylose, but achieved a really high overall protein basically the dry cell weight, the biomass yield amongst all the monosaccharides. So a possible explanation of this is the trade-off between the growth rate and yield, where this fructose metabolism may favor the carbon allocation towards the biomass synthesis rather than basically favor this process. And this could reflect a resource allocation strategy in these fungal cells, which prioritize the long-term growth pattern or potential over instantaneous growth rate. So, as we already touched base, the galactose is much more delayed and demonstrate a really poor, this pink line here, demonstrate quite a poor overall biomass yield. So to conclude, these results highlight the importance of consideration of the, both rate of substrate consumption, but also efficiency of the biomass production. And if we're looking at the dual substrate, previous slide was a single substrate, and as the number here indicate, we show the dual substrate, we can consider the different combination with the glucose, xylose, glucose, galactose. Both mixed sugar system shows a very nice growth profile compared with even a glucose single substrate. This reflects a rapid glucose assimilation consistent with the glucose role as a preferred carbon source and its regulatory, representation of the secondary sugar utilization. This shows a very interesting diaxic growth, as you can see here. There's a diaxic, growth pattern observed in both cases for this dual substrate case, with a very clear sequential consumption of the glucose followed by the secondary sugar, either xylose or galactose. So basically this pattern mirrors behavior seen in the sucrose hydrolysis later, and where essentially the fructose, because the sucrose further hydrolyzed to glucose and fructose. And when the sucrose hydrolysis occurs, the fructose utilization was delayed until the glucose is utilized by the cell. So although despite of this the additional sugar in this dual substrate, the final biomass yield still remained quite comparable with the glucose alone. So this suggests the secondary sugar or secondary substrate was not efficiently converted in this case. So, well, one possible explanation is accumulation of the acidic byproduct during the glucose metabolic reaction and leading to a pH drop. But that also highlights, there's actually the high throughput system without continuous, oxygen observation control can potentially lead an issue. And our ongoing work is explore the other system, system and strategy to improve the pH stability and also, of course, optimize the system. So to summarize the single and dual substrate, and we compared this final biomass yield, as you can see here as a bar chart, and across all the tested different substrates calculated as a gram per gram of the substrate consumed. This provides a very nice direct comparison of the carbon conversion efficiency for each substrate you studied. So what we found here, first, fructose and xylose support the highest carbon conversion efficiency. And of course, glucose yield is slightly lower despite although the rapid utilization rate. Galactose, as we already analyzed in previous slides, supported very slow growth despite a comparable yield to glucose. Well, mixed substrate, either glucose xylose, glucose galactose, achieved yields comparable with glucose and sucrose. All this conclusion mainly, summarized on the right-hand side. This highlights the need to balance the utilization rate and yield when selecting feedstock. So quite interestingly, we also explored, as we mentioned, we explored the real-world case, which is a functional drink waste. And often this waste is not sold off the shelf from the retailers. And often this waste drink, can be utilized and currently is not sufficiently, it's just treated as a waste and disposed to the wastewater treatment system, which is really a shame. So because all this waste drink, which is a food safe, but also contain quite rich carbon nutrient. So we explored potential of using this nutrient and this expired drink, functional drink, as a feedstock to produce a fusaramine atom based, the food grade protein alternative. So this beverage provides, of course, the composition is not completely shown here, but we fingerprint or also we characterized this drink, this substrate pre-hand in the prior experiment. So we discovered that in this very complex functional drink, it contains multiple carbon sources such as sucrose, glucose, fructose, and citric acid, but also contain amino acid and organic acid. So in other words, it's a very rich in carbon and nitrogen and nutrient, which is brilliant. So we really we explore the substrate utilization under this condition, and it's from the results. And on your left-hand side, we tracked this I would call it brown line, shows the cell growth curve, and all these different colors shows the utilization of different molecules. And basically, the biomass yield reached very high. And from the observation, we find that all these different substrate utilization under this condition are super efficient with a rapid and sequential consumption of one after another. And essentially, the total biomass yield from this complex carbon source reached quite impressive, over 55%, well, 56, right, percent, and which significantly exceed the yield observed in the current industry scale, utilizing a single glucose source. Quite striking. So this fermentation showed a very high growth rate of course, reach quite rapid utilization, use within around 65 to 80 hours. And this really preferred or superior performance could be due to the extra buffering capacity of the trace element skeleton provided by the citric acid. As we highlighted, the pH buffering is quite important. In addition, also not directly quantified here in our study yet, but the presence of the small amount of amino acid, malic acid, and vitamin C and other micronutrients present in this functional drink also may have further supported growth and biomass synthesis. And this result shows the proof of the expired drink potential to be utilized. So we try to quantify here. If you look at the UK drink industry, have this amount, well, it's quite a large amount, 362,000 tons per year, and that can be translated into the edible protein, quite striking, 7,500 tons per year. And we, of course, all this rich high-throughput experiment data further feed into the modeling, and we fit into, we try to the unstructured method like monod biomass growth, but also the single and also double Gopis phase. So here all this diagram showing the fitting. Well, we focus here in one is a single sugar and two is a dual substrate, if you recall from the previous slide. And what we found is basically across the different single and dual substrate, the growth curve, the complexity is very much substrate dependent, of course, and shows very much a deviation with from the the monod, which is a very classic kind of monod forced principle based kinetics unstructured method. And this is most likely due to the environmental limitation, as I already shared my view before, of this high throughput method, and which potentially lead to this quite low oxygen transfer rate, leading to the metabolic overflow and the potential effect of pH drop, as we analyzed in previous slides, from the growth associated with organic acid production. So investigating this, we also investigate alignment of the ethanol production, which also indicated the dissolved oxygen depletion occurring. Quite interesting. So what really a takeaway message here we want to highlight? Of course, there shows quite a lot of fitting, including the biomass fit, growth rate fitting of the modeling fitting, and also the ethanol production. But we well captured the growth trend through the modeling in short. However, we discovered that such a complex system with, of course, a lag phase, exponential growth phase, inhibited growth phase, and stationary phase, it's very hard to be captured by a single, unstructured method such as a monod. And this behavior reflects a multi-phase growth trend. And we also further fitted the waste functional drink, as we already shown our experimental results here. We basically also fitted into this multi-Gopis modeling. And the waste functional drink, of course, as we highlighted, it enables the much easier, faster, and growth, and also encourage simultaneously utilization of all this carbon source, which is really yield quite a high biomass for the synthesis. And basically, we also fitted all this, the performance of the biomass growth as A, and as a diagram B, and also, of course, shows we fitted the substrate depletion, as well as also the biomass growth rate into this multi-Gopis, which will capture the growth trend very nice. So that means we can really predict basically biomass growth of the cell behavior using the kinetic modeling and taking a different modeling strategy. In addition to the monoculture, as I mentioned, we also focused on the bioprocess underpinned by the microbiome or microbiome community. And we use the very nicely engineered system called anaerobic digestion. You may know about it. So basically, studies the microbial community, the syntrophic species, behavior and in the system. So if we look at anaerobic digestion, of course, if we analyze the literature through the literature synthesis, we found a range of different microbial strengths, and they also have a different affinity shows affinity to the different molecules and different bacteria and archaea species, shows their different optimal temperature and pH, and most of them are mesophilic, which means prefer the below 40 degree, but some of them are thermophilic, like even above 50. To capture this trend, we designed the experiment and to reflect designed with a single stage bioreactor, continuous running bioreactor, and also the two-stage. And we investigated mesophilic and thermophilic different temperature range. And to further capture the trend, we also take the sample, of course, as you can see here, this continuous bioreactor is we in collaboration with the company, we use a patented technology, and this mimic the large-scale bioreactor behavior, and as including the thermal jacket, this black one. So it's a thermal jacket, keep the while kind of continuous bioreactor under the constant temperature. And all this auto-feeding system is not well shown in this diagram, I appreciate, but that's basically automated system. And we also have the automated the sampling. And basically we have the sample collected, and our researcher, Alan already a postdoc in New York University. And so basically, we collect liquid sample through the colorimetric method or liquid chromatography for the targeted analysis. And we're also doing the sequencing analysis to understand the microbiome patterns and behavior through 16S RNA. And many data are generated, and we are not going to show here, but if you are interested, please feel free to explore our published research in water research, but that already have all the data is in the shared in open source manner. And basically here we will capture the behavior of the microbiome as the taxonomic tree shows here. And we analyze the alpha beta biodiversity, but also we analyze the intermediate products such as volatile fats, basically bioinformatics to predict the performance of the microbiome. And I only show a screenshot of one of our machine learning methods done by Xingyang. So basically, as I mentioned, we correlate the microbial community, the composition, and with basically the chemical, environmental, and operational variables predict at genus and phylum level. For example, here we got a quite nice prediction, and we will kind of track the microbiome behavior. And through this research line, we are trying to understand basically microbiome deterministic behavior. But of course, we are interested in stochasticity, but that's next step of future research. So while we do all this kinetics, the kinetic modeling, such as shown here in the different kinetic modeling fitting, and that would underpin our the process simulation. So it's more like you can imagine that as a computational experiment. And I use this diagram just to reflect the process we talked at the very beginning. We set our view of the wasteful microbial protein and utilize the lignocellulosic behavior. And if we simulate this whole system or process, we essentially take the agricultural waste, as we are familiar with, and further, through the pretreatment and matrix hydrolysis, extract the fermentable carbon, and then feed into the fermentation process as basically produce the eatable mycoprotein. And all this simulation, of course, the real simulator is not this pretty, so it's a very chemical process simulation. And we use simulation as experimental computational experiments and running and get basically the data points from the input-output data. Then we treat it as a black box and use a machine learning method, correlate, and find a mathematical representation to replace the underlying simulation. And that allows us to do the further optimization. And all this hard work is done by the group members. So Ethan, postdoc Ethan and Alex already finished. He's currently a postdoc at Imperial, and Mason is finishing his PhD. So all this work, we really promote, I'll say, believe in open source. We would love to share our research and our developed tools with our peers and community. So if you are interested, feel free to go to GitHub. You will find a range of tools there. So which we developed, and hopefully you find it useful. And as like an optimizer, for example, all this the flow, data processing, and also the fitting, as well as find a surrogate model to further optimize the system, optimize the process, optimize the process design. All this visualized, let's say, a workflow here has been developed as a piece of tool. Optimization tool, or embed the machine learning method and optimization theory, underpinned by optimization theory, has been uploaded to or shared on the GitHub as a repository, public repository. And we further.
Yeah, you have 5 minutes left.
Okay,
5 minutes.
Thank you. Yeah, it's finishing. I'm finishing the. So basically, beyond essentially the bioprocess optimization, we also focus on the bioprocess control, trying to optimize the behavior, and that's including the optimize the monoculture as well as the microbiome system. And beyond this, I would just use a couple of slides and share what other ongoing research. And this is a very striking, I would say the galaxy-like network shows the human, human stack, which is we are trying to capture the basically the different metabolic pathways and so on. So all different omics like proteomics and metagenomics and so on, and essentially offer a very rich data to enable us to do a further discovery. But they are not that simple. If we are trying to find interaction between the metabolized proteins and genes, and their reaction can be linear and can be also circle, or can be even super complex. And what we really inspire here, and we try to develop, we use generative AI and develop the basically model to based on the known biological pathway to predict unknown. So what we achieved here is we are very much inspired by the natural language processing technique. So for example, in the NLP field, if we say Tokyo plus Japan minor UK, and that's essentially it's a link to the directory to London, the capital. So what we really do is we essentially link through the directional context embedding between the pairs, and we bring all the different multi-omics layer into a unified embedding space to form the context-dependent pairs. And this enables us to do further, through generative AI and to predict based on the known, predict unknown biological pathway. And that can underpin the bioprocess design for monoculture, as well as also synthetic microbial community, but also that this method also could get the drug discovery. So we are basically the medical side of the research in this, we are doing in collaboration with medical school at King's. I believe you have heard the presentation from Callum. So always a high throughput platform we presented in the previous slide basically give us the opportunity, to explore further. And what Callum is working on is he showed you his very impressive 3D printed for a liquid handling system, and that's essentially it's a robotic sort of a system enable us to automate the whole process, remove the human interference in the lab. And doing that, we also need to further develop, like a software. For example, we call it a multi-fidelity optimization method, underpinned by Bayesian optimization, or also active learning and so on. So JWOOC is working on the multi-fidelity optimization. And if I use a simple analogy to describe what that is, it's basically the brain of the automated lab. And to basically based on the both virtual lab reflection, like simulation, and a real lab experiment, and to design experiment and optimize the experimental planning. So that is ongoing research. And collaborating with other colleagues, we work on the chemical engineering research with the interaction at chem informatics, and basically predict the molecular behavior and their performance and their features, functions, activities, based on the structure of the molecules. So because today's topic, I focus more on the bioprocess side, so I just want to share what is the other ongoing research. So some food for thought to conclude my talk. So basically, all the bioprocess underpinned by monoculture microbiome offer great potential for biomanufacturing and our future circular economy. And chemical engineering integration with AI can offer a very powerful tool to accelerate discovery, development, and optimization of such a complex dynamic bioprocess. And of course, many unknowns are not yet discovered. So we can do a lot through discover the hidden patterns in the high-dimensional omics data, for example. And cross-disciplinary approach and collaboration yield very exciting research. As I already demonstrated, we collaborate a lot across the different disciplines, which are really exciting, including toxicology, also colleagues in medical school and so on. And I would like to take this opportunity to thank for our founders, as well as the former lab members and current lab members, and some nice photos record our happy moments. And by then, I would like to thank for your attention and stop sharing my screen. Thank you.
Thank you very much for the presentation, Professor Guo. I think it was very impressive research and really comprehensive, from the small molecule into the reactor and its optimizations, and also performing machine learning on all the bioprocess. I think we are moving on the Q&A series, if any questions from the audience. But okay, before that, Dr. Ratna, I have very interesting questions. Dr. Guo, actually I'm working on the biomass conversion into the bioenergy. I'm really matters the particular biomass to convert. Like, for example, when we talk about the corn and when we talk about rice husk, usually the mineral compositions, it matters. For example, like rice husk can convert into like silica, high yield of the silica, but the corn cob, for example, they in the minerals contains a lot of calcium, for example, something like that. In your process for the food, especially for the food, is there any biomass matters for the specific biomass to convert into the protein in your field? Yeah.
Oh, I think you are right. Basically, rice husk and rice agricultural residue offers the potential to produce silicon. That's quite a nice research line. However, here we presented lignocellulosic material weights to mycoprotein, and that's really demand the pre-treatment step, if you like. Essentially, I have to derive the purified. I wouldn't call it purified, but it's like a clean, fermentable carbon stream feed into the fermenter. But yeah, potentially I can see how the other component in the waste can be potentially co-recovered with the microbial protein. And an option would be through the integration of the different existing process, and to basically recover different component of the waste stream. But of course, as you already correctly pointed out and highlighted, different waste stream offer different molecule, chemical composition, and that's really depends on the stream and the need to tailor design the process and for such purpose. But it's a very interesting and a great question. And in my opinion, I don't think in future development we should reinvent the wheel. In other words, we have a lot of know-how and knowledge, and we can build on the prior knowledge and essentially start building more optimal resource utilization, optimal or resource efficient system, and to essentially integrate different process and co-recover different chemical component.
Yes, thank you very much. Very, very interesting talk. Okay, Dr. Ratna, yes, you can ask the question.
Thank you very much. I'm interested in your research, and I have a question. According to you, which one is easier to make and cheaper? Make a biofilm for packaging food application from polymer biodegradable, or by natural materials such as chitosan, or from microorganism?
Okay, yeah. So the question is from Dr. Ratna and Professor Guo. Which one is cheaper? There is a biofilm packaging for food from the biodegradable materials, and another one is
from polymer biodegradable, or from natural materials such as chitosan.
Compared to chitosan or natural materials.
Or from microorganism.
Microorganism. Okay.
Yeah, I mean, unfortunately, we are not really into the packaging field, and that's really need. I would say it's beyond our research, and I think if you really try to understand I can't really comment because we are not really working on that. But I can comment on if you are interested in that research, how you could potentially investigate, and you could through if you are talking about economic performance of the process, and in that case, instead of test error type of experimental in the lab. And of course, we need to think about industry scaling up, right? So I would suggest potentially could consider the technology economic, it's called TA, technological economic analysis through the process simulation, considering the different bioprocess and also other alternative packaging solutions. So essentially, I have to simulate individual process to produce a certain material. And also that process simulation offers a potential. I wouldn't say is give you the ground truth, but is at least offer the first insight. What would be the more scale? What is the scalability and the techno-economic or economic performance of feasibility of the different options? And then you probably could investigate further and do a bit of screening of the feedstock raw material, as well as the screening of the technology. So I only can comment from that side, but unfortunately, we are not working on it.
Thank you. Thank you so much, Professor. Is there any question from the online participants? No? Any?
I can see a hand up. I think it's a moderator. Yeah, no.
Okay, now. So a very interesting topic, Dr. Guo. I think this is the last our discussion, our keynote address today, Professor Guo. Thank you very much for your time, for your sharing. It was really valuable for us. I think we have a lot of part of the collaborations, Professor Guo, in terms of the productions of the food, and also I saw some carbon capture from the production of the food. I think it was really interesting us. Okay. I hope we have more time, Professor Guo, but we have a limited time for these conversations. Thank you so much. We sincerely for your time. Thank you. Thank you so much. Yeah. Big applause to Professor Guo. Okay.
Thank you very much.
Thank you. Thank you. So we move forward to the next agenda. I will give it to the Master of Ceremony, Dr. Imam. Yep.
Thank you so much, ladies and gentlemen. So we just finished our last keynote presentation with a very impressive presentation from Professor Dr. Miao Guo and the moderator Dr. Ahmad Farouk Al-Hikami. Ladies and gentlemen, now it is time for us to have parallel sessions. We just want to announce that our IT team already renamed your name. So you will be divided into breakout room, and the breakout room already set up by IT team. And for your information that we will be back again around 5 p.m. for closing and the announcement of best presenters. So after finishing your presentation, so we would like to kindly invite you to come back again to the main room so that we will have a closing ceremony and the announcement of best presenters of today's parallel session. And while waiting for the assignment from the IT team, I will kindly inform to all presenters to join the breakout room that have been announced in our invite the moderator to room session so that we can start the presentation in each breakout room session. For your information, the IT team already renamed your name based on the naming system that we have provided in the presenters group session. So please kindly join the breakout room session and we can start the presentation in each breakout room meeting. Thank you very much.
And the third goes to Mrs. Nur Hidayati. For the Professor Nur Hidayati, okay, from Universitas Islam Malang, as also the best presenter for today's international conference. And please, ladies and gentlemen, give a round of applause for those best presenters for today's international conference. So, they are not only performing their presentations, but also becoming the best presenters. One of the achievements for the international conference. We express our gratitude for your contribution and congratulations for your achievement. Thank you very much. Well, ladies and gentlemen, we are going to the closing ceremony program actually. Therefore, we would like to invite Dr. Haja Erna Suliastiawati MKes PhD to give her remarks. For Dr. Erna, the time is yours.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. And I think it's good afternoon. Good afternoon or maybe evening, honorable all the distinguished presenters, esteemed guests, fellow researchers, ladies and gentlemen. And all praise and gratitude are due to the Almighty for His blessings that we now arrive at the closing moment in the first International Conference on Biological Technology and Sustainable Nature, or IC-BioTEStA. It feels like only a moment ago we gathered here in the opening ceremony, filled with the anticipation and a shared passion for the future in our planet. And over this day, this whole and its parallel sessions have been a vibrant epicenter of knowledge, a melting pot of brilliant ideas, and a testament of the power of scientific collaborations. And this conference would not have been possible without the dedication and contribution of many individuals and organizations. And on behalf of the entire organizing committee, I would like to extend our deepest and most sincere gratitude to our distinguished keynote speakers and plenary speakers, and then all the presenters, both in online and also offline, and the moderators, and then all the participants and attendees and the esteemed scientific committee and reviewers for your rigorous work behind the scenes, and then our generous sponsor and partners, and the last but certainly not least, my heartfelt thanks to the entire organizing committee and our tireless students, volunteers, and your months and hard work, meticulous planning, and unwavering dedications that have been bedrock on this event's success. And your effort have been truly remarkable. And ladies and gentlemen, let this closing ceremony not be an end, but a milestone. The challenges facing our planet are immense, but as this conference has shown, so our collective will and intellectually capability to address them. The theme Biological Technology for Sustainable Nature is not just a title for an event, but it's a call to actions. With pride in what we accomplish together and with great hope for the future, I now officially declare the first International Conference on Biological Technology for Sustainable Nature is closed. We wish you all safe and pleasant journey home, and we look forward to seeing you again at future scientific gatherings. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Dr. Haja Ena Soleswati MKes PhD, the Vice Rector on Economic and Collaboration Unisma, who has officially closed this international conference. Well, ladies and gentlemen, again, we appreciate our deep appreciation for everyone, for the keynote speakers, all the presenters, all supporting committees, conference chairs, and all the team. Thank you so much, and we hope we can meet again in the next international conference of biological technology and engineering for sustainable nature, maybe in 2026, inshallah. Okay, thank you so much. Let's close our program by reciting Al-Ars and Al-Fatihah. Bismillahirrahmanirrahim. Wal asri innal insana lafi khusr illa alladziina amanu wa amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ar-rahmanirrahim maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Okay, thank you so much again and again. And we are so sorry for any inconvenience during the international conference that we are conducting today. And we hope that we can continue connecting and collaborating, and see you in the next international conference. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you.